it would be 0 because queen is a female. So similar wise, man has a gender, so it will have 1. And women also has gender, so it would be 0 because it's a female. And monkey, let's say it's a male monkey, so I'll assign it 1. Okay. Now it will come to the next features called wealth. Okay. Now here you can see king has wealth, right? Because he's the king and he has lots of wealth. So it would be, let's say 1. I'll assign it as 1. Queen will also have wealth because queen is also part of king. And man will also have wealth, but it would be less than king and queen. So let's assign as 0.5. And women will have also wealth, but less than man. So here I can give 0.3. Monkey doesn't have any wealth, so I'll give as 0. Okay. Now king has power, so I'll give 1. Queen has also power, but less than king, so I'll give 0.7. Man has also power. Let's say man has power, but it's less than king, so I'll give as 0.5. Woman has also power, but it's less than man, so it would be 0.2. And monkey doesn't have any power, so I'll give as 0. Now weight, yeah, king has also weight, so I'll give 0.8. And let's say king is a little bit obese. Queen has also weight, so I'll give as 0.5 because let's say queen is slim and all. Man has also weight, so I'll give it as 0.7. Woman has also wealth, I'll give 0.5. Weight is fine, I think. Monkey also has weight, let's say 0.3. Now king can speak, so I'll give 1. Queen can also speak, I'll give 1. Man can also speak, I will give 1. Women can also speak, I'll give 1. And monkey doesn't speak. Okay, so I'll give as 0. Okay, now see guys, beautifully it has generated, these are the vectors. Okay, by generating these are the features. Now let's see if I want to represent king. Okay, if I want to represent king, so what would be my king vector? So here this is your king vector. So king vector is nothing but 1 1 1 0.8 1. So this is the king vector. Now if I want to represent queen, so this is my queen vector. So queen vector would be 0 1, then 0.7 0.5 and 1. Okay, now if I want to represent man, so this is the man vector. So 1 0.5 0.7 and 1. Okay, now let's say if I want to represent women, okay, I think you are getting it, like how we have generated, these are the vector. Now this is the vector of the women. So 0 0.3 0 0.3 and 0.2 0.5 and 1. Okay, now let's take one 2D dimension, okay, and plot these are the vector and try to understand like what will happen. So let's say here I will take one 2-dimensional space. So let's say this is my 2-dimensional space. Okay, so this is my x and this is my y. So if you plot all the vector here, okay, if you plot all the vector here, you will see king and queen, king and queen will appear to the similar. So here let's say this is my king and this is my queen. Okay, so what will happen whenever you will plot these are the vector to the 2-dimensional space, or let's say 3-dimensional or any dimension, okay, you will see king and queen will appear like very close together. Because if you see here, okay, if you see here, as per the features, if you calculate the number, if you calculate a distance between these are the vector, you will see this distance would be like very less. Okay, that's why king and queen would be appearing very closely together. And here man and woman, let's say this is my man vector and this is my woman. Okay, this is my woman. So these two vector would be appearing closely. And here if you see here, there is another vector called monkey. Okay, monkey will appear completely different from these are the vector, because monkey is a different entity here. So let's say this is my monkey. Okay, now if I show you, see, so it has built one cluster. So this is one cluster, this is another cluster, and this is another cluster. Okay, now if you see here, using this concept called vector embeddings, we are easily getting these are the similarity score. Okay, similarity vector. So now if I want to extract any kinds of vector, okay, let's say I want queen. Okay, I want queen, so it will go to this cluster and will return this vector. And let's say not only queen, let's say it would be, let's say I want something called princess. Okay, I want something called princess vector. So what will happen, it will come in this cluster, because if you calculate the vectors, okay, of the princess, you will see it will have these are the features. Okay, it will have these are the features related to the king and queen. Okay, so now this princess will appear here. So that's how actually this embedding model works actually. So it will first of all assign some of the features, based on that it will generate these are the vectors, and it will plot these are the vectors to the higher dimensional space. So here in this case I have taken 2-dimensional space, but it might be 3, 4, 5 and so on, okay, based on your dimension of the data. So whenever I'm using unstructured data, whenever I'm using real world data, so dimension might be vary. Okay, it might be millions dimension, it might be 1,000 dimension. We can't say like what are the dimension it will have, but as a visualization we can only show 2D space here. Okay, so this is the complete idea, guys. I think you got it, like how these embeddings model are working, okay, and how it is generating these kinds of vector. Okay, now here in this case actually you have lots of embedding models. So we have OpenAI embedding model, and this model is trained on GPT. Okay, GPT model, I think you have heard of GPT model. Then we have something called Hugging Face embedding as well. Okay, Hugging Face embedding. So it is already trained on, let's say, lots of open source LLM. Okay, that means large language model. Then we also have something called Llama. Okay, Llama 2 embedding. I'll be discussing like what is Llama 2 and all. Okay, as a open source model. Then we have something called Google Palm embedding. So these are the open source embedding you can directly use. So this is from Facebook research, okay, and this is from Google research. Okay, and this one is paid, because if you are using OpenAI embedding and OpenAI model, so you need to pay. This is completely paid, and these are the things are free. Okay, these are the things are open source and free, but to get the Llama 2 access, actually you need to send some information, then they will give you the access. I'll tell you like how to take this Llama 2 access and all. Okay, everything I'll be discussing about. Don't worry about, like, just try to stay with the video. I'll be discussing each and everything. So guys, I hope you got the entire idea, like how these embeddings models works, okay, and how it generate these kinds of embeddings as a vector, right? So guys, here I kept another example. If you just see this example, your concept will be very much clear. See here, I have these kinds of words, okay, and we are using these kinds of embedding model, and we are generating these kinds of vectors. And if we plot these are the vectors to the 2D dimension, so it will look like that. So let's say we have this 3 word, we have this 3 word, and we have this 3 word, and we are getting different vector. And this is the cluster. Okay, this is the cluster of each of the words. If you see here, king, man, women, it's appearing in the same cluster. Then apple, banana, orange is appearing to the another cluster, and football, golf and tennis, it's appearing in the another cluster, because this is related to a person. Okay, person, and this is related to fruits, and this is related to sports. Okay, that's why this cluster is different. Now I think you got it, them vector embeddings, like how this vector embeddings looks like and how it is generating. Okay, I have given you the entire idea. But one issue actually with this vector embeddings, which is nothing but whenever you are getting any similar kinds of vector, it is applying something called a distance formula. I think you have heard of like distance formula. We have Euclidean distance. Okay, we have Manhattan distance, or let's say we have something called cosine similarity score as well. Okay, so using these are the equation, actually it try to calculate the similar kinds of vector. But again, if you see here, it would be very much time taking, because it will calculate with respect to one by one all the vector, then it will give you the similar kinds of vector. So the main problem is like the time. If you are using this thing directly, so it will take lots of time to give you the similar kinds of vector. So to overcome this issue, actually they propose something called indexes in the vector database. Okay, like we call it as vector indexes. So what is vector indexes? So let's say whenever we are having these kinds of unstructured data, we are applying this kinds of embedding model, and it is generating these kinds of embedding. Okay, so on top of this embedding, where what it's trying to do, it is trying to add some kinds of indexes. Okay, so this indexes is nothing but it's a data structure. It's one kinds of data structure actually. So what it will do, it will find out similar kinds of vector and it will assign some of the indexes. Okay, and it will make some cluster kinds of thing. So whenever, let's say, you have any new data, first of all it will see like which indexes actually it lies this data. So in that index only it will search that query. So to understand this, let's say this is my example. So first of all, let's say it has assigned these kinds of indexes. Now you have one new data. Now first of all it will see like which cluster actually this is lies. Okay, so it will go to that cluster, then it will return the similar kinds of vector with respect to the new data you are giving. Okay, instead of searching to all of the clusters. So this is the idea of these indexes in this vector database. Now using these indexes to our vector database, it's like very fast. Now whenever you are asking any kinds of query to the vector database and it is returning any kinds of vector, so this process time would be very fast. Now guys, I hope you got the entire idea like what is a vector database and all about, and what is embeddings and all about. Now you can tell a vector database indexes and store vector embeddings for faster retrieval and similarity search. So we used to use our traditional database to directly store our data, but in the vector database, first of all, we try to convert as vector, then we try to store them to the vector database. Okay, this is the complete idea. Now guys, let's discuss some use cases like why this vector database is useful, like what are the use cases are there. So as you can see, it will help you the long term memory for the large language model, because it is storing all of the data as a vector to the vector database. So whenever you are connecting this kinds of large language model to the vector database, so it can be used as a memory. Okay, memory of your large language model, like long term memory. And it can also perform something called semantic search. I already told you how to perform the semantic search using the formula and using the indexes and all. So search based on the meaning of the context. Let's say if you're giving something called, let's say, king and queen, so it will not only consider the text you are giving, it will also consider the context, like what is king, what are the features of king, what is the features of queen. Based on that, it will give you the similar kinds of vector, okay, as a output. Then it can also perform something called similarity search, as I already told you, like on the text data, image data, video data, or let's say audio data. Let's say I have one image, let's say dog image. I will tell hey, just give me some dog images, okay, similar kinds of dog images. So it will first of all try to see the vector, okay, similar kinds of vector, and it will return the similar kinds of representation of the dog to you. Okay, so we call it as similarity search. Then it can be also used in the field of recommendation system, because as you already saw, like if you are having these kinds of vector together, and it can perform similarity search. Let's say I want to build something called recommendation system. So let's say I'm asking for like food related content, so it will suggest me food related content only, okay, using these kinds of similarity search and all. So guys, this is the entire idea of this vector database, and these are the use cases actually you can consider, okay, inside this vector database. So guys, I think so far everything is clear. Now let's try to see some widely used vector database. So you can see we are having ChromaDB, Weaviate, then Fias. So Fias is implemented by Facebook AI. Then we are also having Pinecone, then Neo4j. Neo4j is a graph-based vector database. Okay, so these are actually very common vector database people are using in the market, and it's like very famous vector database, okay, in the market right now. So here we'll be exploring all of them one by one. So in the next video, we'll try to see how we can use ChromaDB, and ChromaDB is a local vector database, and this Pinecone, Weaviate, Neo4j, it's a cloud-based vector database. Okay, and here is another vector database. You can see Fias. Fias is also a local vector database. That means if you want to, let's say, store your data as a locally, so what you can do, you can use ChromaDB or Fias, and if you want to store them in the cloud, you can use Pinecone, Weaviate, or Neo4j. Okay, so now in this video, actually we'll start with one practical demo. That means we'll be learning one amazing vector database, local vector database called ChromaDB. You can see ChromaDB is a local vector database, so they're also bringing the hosted version of the ChromaDB. So you can see it is still under development. So once it is done, you will be also able to let's say use this ChromaDB in the cloud server as well. So as of now, if you want to store your, let's say, embeddings in the local, okay, that means if you want to set up everything in the local, you can use ChromaDB vector database for this. So this is the documentation of ChromaDB, guys. You can see this is the official documentation. So they have given each and every guideline, so you can follow this documentation, like how we can set up and all. Okay, so what I will show you guys, I will show you one complete practical. That means we'll be experimenting this ChromaDB on the Colab notebook. Okay, so guys, let's open up my Colab notebook and let's see how we can use this ChromaDB vector database. So guys, as you can see, my notebook is connected. Now, if you want to test it, whether it's working or not, just write one message here. So I'll just write print. Okay. So it should So it's working fine. Okay, so now the first thing, I'll be installing some of the like required packages. Like I need to install the ChromaDB and all. So there is the guide actually they have given, like you need to use pip to install the ChromaDB, and how to like set the client and all, everything they have given. Okay, so first of all, what I will do, I will just set up this ChromaDB. So to set up the ChromaDB, you will need some more required package. Okay, some more dependency. I'll tell you like what are things you need. So just write pip -q install. First of all, I need something called ChromaDB. So I'll copy the name from here. ChromaDB. Then I need something called OpenAI, because I'm going to use OpenAI embeddings and OpenAI, like you can say LM model. Okay, that means GPT 3.5 turbo model. So that's why I need OpenAI. And I also need something called LangChain, because I told you I'll be using LangChain here. LangChain, and there is another dependency you need, something called tick token. Okay, tick token. So if you are using OpenAI embedding, so you need this package actually, tick token. Now, yeah, I think these are the things actually I need. Now let me install it. And guys, you need OpenAI account for this video actually. So just try to create an account here. Otherwise, you won't be able to do it, because you need the OpenAI API key, okay, to run this, like you can say, notebook. So guys, installation is done. Now, if you want to see, let's say, any version of any package, so what you can do, let's say I want to see the ChromaDB version. So I'll just copy the name, and here you can just write pip show. Pip show, and just give the name of the package. Now if you execute, it will show you the version and every information about this package. See guys, name is ChromaDB, and this is the specific version, and this is the entire summary of your like ChromaDB package. Okay, so that's how you can see for all the packages, okay, you have installed. Now here, first of all, I need to download some data, because here I'm showing you vector database example, and there actually I need the data, okay, to show you like how to store and all. So for this, actually what I will do, so there is a actually this Dropbox links, actually you can see this is the Dropbox links, and inside that actually you have some article data. If you see, Google article is there, then you have some AI startup article, Amazon article, then you have Databricks article, chat GPT article. So we have different articles here, okay, and this is a txt data, txt format data. Now if I open any kinds of txt file, see, this is the article related to this default, okay, generative AI. So they have written all the article and all, okay. So I'll be using these kinds of data. You can use any kinds of data, it's up to you, but this is the open source data actually I got from the internet, and this is the link of the data. So to download this data, first of all, I will copy this link, and here I'll be using something called wget to download this data. So I'll just write wget. So wget is a Linux command, and here we are using Google Colab, and Google Colab is running on the Linux operating system. Okay, so it is running on the Linux kernel. So that's why you can execute any kinds of Linux command here. So here I'll just write wget -q, and here I'll just paste this link. Okay, I'll paste this entire link. Now once it will download, let me show you how it will download. So if I execute this cell, left hand side you will see it will download that zip file. Okay, see, new article.zip file, this zip file has been downloaded. Now I also need to unzip this zip file, so I'll just write unzip -q, and this is the name. I'll just copy the name. I'll just copy the name, and here I'll just tell the directory like where you need to I mean unzip it. So I'll give the same name. So this is the name, new underscore articles. Okay, so it will create one folder, new underscore articles, and inside that it will unzip everything. Okay, now if I show you, it's done. Now if I refresh the page, I think inside new articles, now see guys, all the articles are present. Okay, now let's see, if you want to open it, you can also open and see. So this is the article and all about. So now let me close this thing. So we have successfully downloaded our data. Now what I need to do, I need to first of all create one OpenAI API key, and I'll be setting up my environment. Okay, So for this, actually, what I need to do, I'll first of all open up my OpenAI account. So you just also open up your OpenAI account. Just size, just search like openai.com, and here just try to log in with your account. So let me quickly log in with my account. So guys, as you can see, this is my account. Now here, I'll just click on this personal, my this is my profile. I'll click here, and here you will get one option called view API keys. Okay, now I'll click here, and here you will see API keys option. Okay, now see, previously I created some of the API keys, that's why you can see here, but for you it might be completely empty. It's completely fine. So you'll get one option called create a new secret key. Okay, just click here and just give the name. So in this case I'm using vector db. So vector db, I'll just name it. Okay, you can give any name. I'm just giving vector db and create the keys. Now you need to solve one puzzle here. It will verify whether it's a whether you are a human or not. Okay, so I'll just click here. Now it's telling just try to move this object with respect to this hand direction. So let me move it and submit. I think yeah, attempt is complete. Now I will get my secret key. Yeah, now I'll copy this key, and here I'll paste it. Okay, as of now I'll paste it, and I'll just give a comment here. Setting up, setting up environment. And don't share this key with anyone, guys, otherwise they will also able to access your like you can say OpenAI account. I will be removing these keys after this recording, so that's why I'm showing. Now here, first of all, I will import operating system package called OS, and here I'll set the environment. So I'll just write OS dot environment environ. Okay, and here you just need to give the keys, like which name you need to save it. So I'll just give OpenAI underscore API underscore key, and equal to, I'll set my API key here. So this is my API key. I'll copy, or I'll cut it, and here I'll set it. Yeah, that's it. Okay, now I can remove this cell. Now let me execute. Done. Now I need to import some of the necessary library. So import. So first of all, I need to import something called Chroma. Okay. So if you're using LangChain, so LangChain already has this Chroma API, because I already told you the integration. So it is the integration with the LangChain as well as the Llama index. So instead of like importing directly, like import Chroma, okay, import Chroma, we have to import it like from the LangChain itself, because here I'm going to use LangChain framework, okay, to build my application. That's why I need to call it from the LangChain. But let's say if you're using it for any other like task purpose, let's say you are not creating any generative AI application, let's say you are doing some different thing, okay, different application, at that time you can directly import it, and all the functionality will remain same only, all the code will remain same only, you just need to change the import, okay, at that time. So here I'll be using LangChain, so I need to import it from the LangChain itself. So how to import it? So just write from LangChain dot vector store. So there is a function you will get called vector stores import. So I'll import my Chroma. So I'll just write Chroma. Then I also need to import uh, OpenAI embedding, because I think you remember. Let me open my board. I think you remember, first of all, what I need to do. Let's say I have my unstructured data. So let's say this is my data. So the first place what I need to do, I need to use something called embedding model. Embedding model. So this model might be anything. So in this case, I'm going to use OpenAI embedding model. OpenAI embedding model I'll be using. So you can use any model here. Okay. Then after that, it will return me my vector embedding. Vector embeddings. Okay. And that vector embeddings I will store inside my vector database. Okay. vector db. So in this case, I will be using something called ChromaDB. Okay, so this is the complete idea. So first of all, I need to import this embedding model as well. So here I'm going to use OpenAI embedding, so I can directly import OpenAI embedding. So let me do it. So here I'll just write from LangChain dot embeddings import OpenAI embeddings. Okay. Then I also need to import OpenAI because I'm going to use OpenAI large language model. So again, I'll just write from LangChain dot LLMs. That means large language model. I need OpenAI. Then I need to load my data. As you can see, this is my data and it is present inside a directory. Okay. And again, this data format is a TXT data. Okay. If you see, it's a TXT data. So for this, I again need two libraries. So I'll just write from LangChain. So guys, I'm expecting you are already familiar with this LangChain because if you check our YouTube channel, so we have already covered this LangChain tutorial and all. Okay. So you can go with that tutorial and you can learn the LangChain. So here from LangChain, there is a class called document loader. So just write document loaders. Okay. So first of all, I'll be import something called directory loader. Okay. Directory loader, because my data set is present inside the directory. That's why I need this directory loader. Then I also need to load my text loader because it's a TXT data, right? So I'll import the same thing only. Sorry, it should be data loader, I think. Document loader. It's a document loader. Okay. Now it should be text loader. Okay. Yes. So as of now, I need these are the libraries, and if I need anything, I will be importing later on. So let me just quickly import them. Now we'll be loading the documents. So load data. So guys, to load the data, just write directory loader, and inside that you just need to mention the directory. So here this is the directory. I'll just copy the name, copy path, and I can give it here. So this is the directory, and inside that actually I have txt data. Okay, I have, if you see, I have txt data. So I only want to load the txt file. So if I, let's say I have some any other file, okay, I will be ignoring. So for this, there is a parameter you can give called globe. Okay, just write globe equal to, so it should be txt file. So all the file just load. Star means all the file. Okay, it should be dot txt. Then you also need to define the loader class. Okay, so just write loader class, and it should be my text loader because all the file are txt format. Okay, that's why you need to give this text loader. Okay, now it will load up your data, and I'll be storing this data inside a variable called loader. So this is my object of my data loader. Now let me execute it. Now to load the data, you need to call one function called loader.load. Okay, if you call this function, it will load the data, and this data will store it in a variable called document. Okay, and see guys, it will load all the data inside this document. See guys, this is the all of the text actually you can see here. So it has loaded all the txt file one by one, and it has extracted the data, and this is your entire data, as you can see. So let me show you. See guys, and this is a document object. Okay, this is a document object. Now we have successfully loaded our data. Now guys, before converting this dataset to the embedding and storing it to my ChromaDB, first of all, I need to apply something called text splitter on top of it. Basically, I need to convert my entire data as a chunks, because as you can see, this is my complete corpus. Okay, see, this is my complete corpus. If I show you, so if I show you the data, see, this is the complete data. Okay, this is the complete data corpus, but this data set is like very huge. Okay, I can't like you can say directly convert it to vector. Okay, so if I'm converting, so what will happen? Okay, let me explain. So what is the use of this chunks? Okay, so see, So whenever you are using any LLM model, okay, whenever you are using any LLM model, so it has one input size, okay, it has one input size, as well as it has one output size, okay, output size. So whenever you are giving something as an input to the LLM, okay, you need to always take care about the input, okay. So I'll tell you like where you need to check the input size and all. So in this case, let's say I'm using OpenAI LLM, okay, OpenAI LLM. So OpenAI LLM wise, I'll be using something called GPT 3.5 Turbo. So there is a model you will get from OpenAI called GPT 3.5 Turbo, and it has actually one specific input length. So that input length actually you need to see. So if you want to check the input length, just search like OpenAI models. So this is the link, just open it up. And here you will see all the models are available inside OpenAI. So we have GPT-4, GPT 3.5, GPT based DALL-E, okay, GPT-3 Legacy. So these are the model actually. And here I'm going to use this GPT 3.5 series. So I'll just click here. Now here if you see, the first model is GPT 3.5 Turbo. And this is the description about the model, okay, like what are the things they are doing and all. And this is the max token length, as you can see. So it can take an input around 4,097 tokens, okay, at a time. And this is the training data, okay, like up to September 2021 they have trained the data, okay. So this is the input length, okay. But if you check your input here, if I open my data, if you see, this input length actually will be more than this 4,000 token, because here if you see, I have loaded the entire documents, all the articles I have loaded, okay. So there is a possibility this input size would be more than 4,000 tokens, okay. And if I'm converting all the corpus as my vector embeddings and I'm storing to the vector database, so it will create issue, okay. So again, during storing it will create issue, and whenever you will be giving this data to your LLM model, again it will be creating issue, and you will also get some memory error and all, okay. So it's better to split our data as chunks, okay. Now what is chunks? So let me first of all tell you, chunks is nothing but, here I have already written, chunks is a size of the maximum number of the character that a chunks can contain, okay. And there is another concept called chunks overlap, okay. So chunks overlap is nothing but this is the number of character that should be overlap between two adjacent chunks, okay. So let's say, so to explain this one, let's say I will take one text here. So let's say this is my entire corpus, okay. Now first of all I need to convert it to chunks, okay. Chunks means I'll be taking some of the chunk size, okay. Let's say if I am writing chunk size is equal to, let's say, 500, so it will take let's say I'll take a new color. So it will start from here and it will go and it will count like 500 character, okay. It will count 500 character. So let's say this is this will end here, okay. This will end here, and this should be one chunks, okay. This should be one chunks, okay. So again it will start from here, again it will count, let's say, 500 word 500 character, and we call it as a token, okay. So let's say this is the here it will end. So this should be another chunks, okay. So let's say this is another chunks, this is another chunks. Now again let's say it will start from here, again it will count, let's say it will end here, this is another chunks. Let's say again it will start from here and let's say it will end here, okay. I'm taking it randomly, just try to consider. So this is another chunks and it will start from here, it will end here, okay. Now how many chunks we have got? So 1 chunks, 2 chunks, 3, 4 and 5, okay. So here I got 5 chunks, okay. 5 chunks of the data. See, now if you count this input length, okay, now it should be less than my 4,000. I think what is the number? It should be 4,097, okay. 4,097, okay. Now my input size is less than 4,097, okay. So this is the idea of creating these chunks, okay. Instead of converting my entire corpus to the vector, first of all I need to create as the chunks, okay. Then I need to convert it to vector embedding, then I will be storing, and that embedding I will feed my LLM model, okay. And there is another concept called chunks overlap. Okay, so what is chunks overlap? So if you set this chunks overlap, let's say I will set this chunks overlap, chunks underscore overlap. Let's say I have set as 20. So what it will do? So whenever, first of all, I will grab, these are the chunks. Okay, now let's create a new chunks again. So let's say whenever it will create a chunks, let's say it will start from here and chunk size is 500. So let's say it will end here. Now you have mentioned chunks overlap is equal to 20. Now what it will do, instead of starting from here, it will go back and it will count 20 character. Okay, it will count 20 character. Let's say this is my 20 character. Okay, now it will create the chunks from here. Now again it will count, and let's say your 500 character will end here. So this is my another chunks. Okay, so basically chunks overlap means like how much overlapping you are needed from your previous chunks. Okay, so that is called chunks overlap. So it helps you like to understand your context of the text. Okay, instead of using only chunk size, you can also use chunks overlap, so that it can also got to know like what was the previous context. Okay, whenever it will, let's say, see, I'm giving this chunks by chunks. Let's say this is my chunk 1, the chunk 2, and chunk 3. So okay, so instead of giving directly the chunks, if I'm also mentioning chunks overlap, so what will happen, your LLM model automatically will get to know, okay, so this is the context actually. So this sentence, okay, this sentence and this sentence, so after this sentence actually this sentence is coming. Okay, so that's why this chunk size, this chunks overlaps actually helps us. Okay, this chunks overlaps actually help us to understand the context of the entire story. Okay, so that's why we'll be using these two concepts called chunk size and chunks overlap. Okay, now I think this thing is clear. Now let me show you how to do it using code. So I'll come here. Now here, first of all, you need to import something called recursive character text splitter. Okay, so from LangChain dot text splitter, text underscore splitter, import recursive. So recursive character text splitter. Okay, so this is the class actually we'll be using to convert my entire corpus as a chunks. Okay, now I'll just call this class, and inside that you need to mention two parameter. I think I already explained. One is your chunk underscore size. Okay, chunk size. So let's define as 1000. Okay, I am considering 1000 character as my one chunk. Okay, you can give any number. So it's a hyperparameter tuning. You can set any number here, but I saw like people are starting with 1000 here. Okay, and there is another parameter you will give called chunk underscore overlap. So chunk overlap, I'll give, let's say, 200. Okay, so again it's a hyperparameter tuning. Now guys, I've created this object. Now I will save this object. So I'll just create a variable called text splitter. Now guys, finally I will convert my entire corpus to my chunks. So I'll just call this object, and here you need to call split dot split underscore documents, and this is my entire documents. Okay, this is my raw documents, so I'll give it here, and I'll store in a document variable. Okay, or I can store it, I think, in a text variable. I think it should be fine. So let's make it as separate. Now let me execute. It's done. Now if I show you my text, guys, so you will be able to see it has converted to chunks, and how many chunks it has converted I will also show you. See guys, so if I just go up, so guys, see, this is my first chunks. Okay, and it is ending here. Then again it is another chunks. Okay, then it is ending here. Then again this is another chunks, and it is ending here. And from and if you see, in each chunks actually you have 1000 character. Okay, 1000 character. And here if you see the chunks overlap, so if you read this text carefully, so you will see some of the sentence are coming, okay, in these new chunks as well. Okay, because we have set this chunks overlap as 200. Okay, so see, this is my entire chunks. Now if you want to see the length, like how many chunks it has created, so just print the length. So I'll just read as my text. So it has created 233 chunks, okay, altogether. Now it's fine. Now if you want to see any chunks, specific chunks, you just give the index. Let's say I want to see the number 1 chunks. This is the number 1 chunks, and I can also print number 2. Now we have successfully converted our like corpus to chunks. Now what I will do, I will create my db object, okay, like vector db object. So just write the comment here, creating db object. So as I already told you, ChromaDB is nothing but it's a local database. So first of all, you need to create a local like DB here. Okay, local DB. So you need to specify the name. So here I already prepared this code. So here you need to first of all create one persist directory, and the name can be anything. So here in this case I'm giving as DB, that means database, and you need to specify the embedding first of all. Okay, like I think you know why we need the embedding, because first of all I need to convert my text to embeddings. Okay, that means vector. Then I will store this vector, okay, to my vector database, which is nothing but my ChromaDB. So in this case I'm using something called OpenAI embedding. I think you remember, here we imported. So OpenAI embedding, so I'll just call it OpenAI embeddings. And by default, if you execute this code, so let me show you which embeddings model it is using. So it is using something called text embedding ADA model. Okay, 002. This is the model. Now you can search also here. So if you check here, so it has this model called text embedding ADA 002. Okay, so this is the model. It has also another version, text ADA 001. Okay. Now we have successfully loaded our embedding model. Now what I need to do, I need to create my vector instance. Okay, I need to like create my vector database instance. So to create it, so this is the code for it. It's a simple code only. So first of all, I have created one variable called vector db, and here I'm just calling my chroma. I think you remember we imported chroma from my LangChain. I'm just calling this chroma. So inside chroma, you have one function called from documents. Okay, from documents. Now here you just need to give the data, like you just need to give your text, like you just need to give your chunks, like which chunks actually you want to convert as a vector. So in this case, this is my chunks called text. As you can see, this is my text. I'll just copy the name, and here I'll just name it text. Okay, and it will also take the embedding model. Okay, so this is the embedding model I want to use. So in this case, you can use any embedding model. You just need to import it here. Okay, so here I'm using OpenAI based embedding model, so that's why I have initialized it here. So here I'm giving the embedding model, and here you also need to give the persist directory, like where it will save after, let's say, converting to vectors, where it will save. So it will save inside this db folder. Okay, so here I'm giving the directory. So these three parameter users only need to give here. Okay, that's it. And if you're not giving any embedding model inside ChromaDB, it will automatically take OpenAI embedding model. Okay, I think they have already written here. If you see here embeddings, so they're automatically, I think, taking some embedding model using OpenAI API key and all. Okay, so they have already mentioned here, like it will automatically load, but it's better practice to mention. Okay, always better practice to mention here. That's it. Now if I execute it, so first of all, what you will do, I'll just remove this directory. Now see, it is converting everything to the vectors. Okay, all the text has been converted to vectors. Now I need to save it to my disk. Okay, now see, it has converted everything to the vector. Now I need to save it to the database. Okay, now this is the code for it. Just write vector db persist and vector db is equal to none. Now if I execute it, now you'll see it will create one db here, local db. Now if I refresh, see guys, db has been created. Now inside that, it has saved all the vector. Now see, it's a binary format, you can't see the vector here, so that is the issue with this local db. But whenever I will be showing you like Pinecone and Waviate, you will able to see the vector, like how it has generated the vector. Okay, how it has generated the embedding, everything you can see in the cloud. Okay, you can like see all the list of the vector there. Okay, so that was the beauty of this cloud vector database, but again it's a local one. Okay, so that's why it's a binary representation here. So yes guys, we are successfully able to save our vector here. Okay, now let's say you want to load it. So how to load it? So this is the code for it. So here you just need to mention chroma. Okay, just call the chroma, and here you just need to mention the directory you have your data. So this is my database db. So here I'm giving the persist directory, which is nothing but db in this case. And here you also need to give the embedding. Okay, so this is the embedding I'm using. Now here I'm giving my persist directory. So in this case it's db. Okay, now it will automatically load this vector and everything. Okay, from this db itself, because it's a binary representation, I already told you. Okay, and as well as I'm also giving my embedding model. Now let me load it. Now I think you remember I told you something called similarity search. Okay, now once we have loaded this vector, to my vector database, now you can apply similarity search on top of it. Okay, we call it as retriever. Okay, retriever. So now let's show you the demo of the retriever. So I'll just comment it out, make retriever. Okay, so to retrieve any specific information with respect to the question you are asking, you need to set this parameter called vector as retriever. Okay, vector db. So this is my object, vector db as retriever, and this is my retriever object. Now let me execute. Now here I'll just call this retriever object, and here there is a parameter called get retrieve documents. Okay, that means I'm trying to tell my vector database whatever question I'm asking, try to give the similar kinds of you can say data, okay, with respect to the question I'm asking. So here I'll ask one question. Let's say here I have Microsoft articles as well. I think if you see here, I think Microsoft articles is also there. So I can ask one question, just like how much how much money did Microsoft raise? Okay, so let's say this is my question. Now by default, uh, I'll store it in a docs. So by default it will return for a relevant answer. Okay, for relevant answer. If I print it, see, it will return you for similarity answer. Okay, for most similar answer. Okay, like whatever vector are closed, I think I was explaining in the theory. So it is the most relevant and most similar answer. Okay, for most similar answer. So if I show you the length, so you can also set this parameter like how many relevant information you want. See, it is returning me 4. So let's say you only want, let's say, 2 relevant answer. Okay, so in this case you can set this parameter vector db as retrieve, search keyword as k2. Okay, k means like how many answer you want. Okay, so let's say I have given 2. Now if I execute it, okay, done. Now if you want to see like search type, so it's a similarity matrix. I think they're using similarity equation, they're using cosine similarity to calculate this answer. Okay, like the question you are asking, basically it will match with the vector, like what are the closest vector, okay, it will come, so it will return you. So they're considering this similarity cosine similarity matrix, I think there. Okay, so cosine similarity equation, and this parameter will give you like number of return actually it will provide. So it will only provide 2 answer. Okay, 2 answer. Now if I again execute this code, now see guys, now length is 2. Okay, it is only returning 2 answer. Okay, so using this parameter you can set like how many like answer or how many similar answer you want, okay, from your database. Okay, now see guys, it has written 2 or let's say 4 similar answer, but I want a specific output. Let's say the question I asked, okay, let's say if I print my document, so it's a different kinds of answer actually it will return. Okay, but it's not understandable actually. It's like it is giving like lots of answer and all. Okay, it's giving lots of text, but I want like a relevant answer. Like I just asked like how much money did Microsoft raise, so it should give me like that is the money Microsoft raised. Okay, so it should give me that kinds of answer, but it is returning this kinds of document. Okay, these kinds of chunks. So to get a specific output, okay, from your data, you can take a help from the LLM. So what you can do, let me show you the diagram. So let's say this is my vector db, okay. Now we have stored our vector embedding here, vector embedding we have stored here. Okay, now you are giving any kinds of query. Let's say this is your query. So here in this case, let's say you asked like how much money Microsoft raise, right? So this is your question. So it is returning, let's say 4 or let's say 2 output documents. Okay, but this 4 or 2 output documents is not readable. Okay, I am not getting my specific answer. So what I can do, I can integrate LLM model. So let's say I will initialize my large language model here, which is nothing but GPT 3.5 turbo in this case. Okay, turbo. So I'll give this answer to my LLM model. Okay, I'll give this answer to my LLM model, and LLM model will analyze this answer. It will also analyze this query. Okay, it will also analyze this query. With respect to that, it will give me the authentic output. Okay, the correct output, correct, meaningful output. Okay, that is the power of LLM. I think you know why it is powerful and all. Okay, because it has trained with huge amount of unstructured data, so it can perform all kinds of tasks. Okay, that's why uh, we will be using LLM, okay, to retrieve our specific answer with respect to the specific question I'm asking. Okay, so this is the idea. So now to do it, actually, first of all, I need to make one chain. Okay, so let me just comment it out. I think you know what is chain in LangChain. Okay, so I'm not going to explain because I think you already learned this chain in LangChain. Okay, why we use chain and all. So first of all, I need to import something called retrieval QA chain. Okay, so I'll just write from LangChain dot chains import retrieval. So whenever you are using vector database, okay, it is returning retrieval output, right? Like related output. So you need to use this retrieval QA. That means retrieval question answering chain. Okay, so it will help you to ask the question, okay, to the data actually you have stored in your DB. Okay, so that's why this chain is required. Retrieval question answering. So I'll import this chain. Now here, first of all, you need to make one chain. So I have already made one chain here. So this is the chain. So I'm just calling retrieval QA chain, and there is a function called from chain type. So here you need to specify the LLM model. So here in this case, I'm using OpenAI LLM model. Okay. So let me show you how it will give you the model. So if you just run it in a new cell, now if you print this LLM, so this is nothing but your GPT 3.5 Turbo. Yeah, so it's not giving the name, but if you see the documentation by default, whenever you call OpenAI, so it will give you something called GPT 3.5 Turbo. Okay, this model actually, if I GPT 3.5, so this model actually it will return. Okay, so I'll be using this LLM, and here I'm giving this LLM model, and chain type is stuff. Okay, I think you already know what is chain type and all. And retriever, so you need to give the retriever object here. Okay, this is the retriever object. So basically, whatever question you are asking, okay, whatever question you are asking, it will return you from this retriever, right? Because you have given this retriever here. Okay, so that's why you need to give this retriever object here, and you also need to give the return source documents. Okay, return source documents means it will return the source also. Like, see, we have lots of data here. If I show you, we have lots of article here. Okay, now which article it is referring to give the answer. Okay, it will also give you as a reference that article. Okay, so this is the idea of this. Now if I execute, now let's ask one question and print this response. Okay, so here I'm calling my QA chain, and this is the query. Same query I'm asking, how much did Microsoft raise the money. Okay, so this is the query I'm giving inside my chain, and this is the response of the LLM. Now if I print this, see guys, this is the query. Now it's telling around $10 billion. Okay, raised like this Microsoft, and this is the source document. Okay, but it's not readable. So what you can do actually, you can write one function here, process LLM output or process LLM response. So this is the function you can write. So whatever response it will give, it will process only, like it will give it the result, source, and the answer. Okay, now if I execute, now if I call this function here, now I'll just remove this response here. Okay, now I think it should give me the yeah, so now you can see this is the clear output. Now around $10 billion, and these are the source. Actually it has referred this to file as a source. Now see guys, we are able to successfully store our vector to the vector database, and we are also able to make the query on top of that. And we also saw that like how we can found the similar kinds of you can say output, okay, using this retrieve. Okay, using this retrieve option. Okay, so you can ask any different question also. So let's say I will ask another question here. So what is the news about Pando? So there is again another Pando articles you will see inside the data. Now again I'm giving inside my chain, and it is giving the response, and I'm just processing the response. Now see, Pando is a startup that has raised $30 billion in a Series B round, and bringing its total raised. Okay, so this is the complete answer. and this is the source it is giving. Okay, I think I don't need to print this. Yeah, so this is the source. So yes guys, that's how actually you can do it. And one thing I also want to show you, like how to, let's say you want to delete this database, so how to do it. So deleting DB, so it's like very easy. First of all, you can make a zip file, okay, of your existing DB, so that later on if you want to retrieve it, you can retrieve it. Okay, so first of all, I'm making it a zip file, then I'll be deleting it. So first of all, I'll make a zip file. Now see guys, if I refresh, so first of all, it will make a zip file of this DB. Okay, now I'll be deleting. So this is the deleting code. So it will clean up everything. Now if I refresh, now see database has been deleted. Okay, now let's say you want to um, get your previous DB. Okay, like you had, let's say some specific or let's say important vector there, you want to get back. So what you can do, you can unzip that zip file. Okay, so this is the zip file, you can unzip. Now again your database will come. Now what you need to do, you need to restart the runtime. Okay, so just click here and there is option called restart the runtime. If you restart the runtime, again you can able to use your DB same wise. Okay, like we already imported our DB right here. So here, that's how you can load your DB again. Okay, so this is the functionality actually ChromaDB provides. Okay, if you see the documentation, they have written everything. Even they have also given the starter notebook and all. Okay, so guys, I think as of now you got the entire idea about the ChromaDB, like how we can use ChromaDB vector database and how we can connect the large language model and how we can perform this let's say vector search operation, right? So one thing I just wanted to show you, see, if you click on the integration, see, this ChromaDB is having like different integration. That means you can use ChromaDB with OpenAI, Google Gemini, Cohere, Hugging Face, okay, Instructor, Hugging Face embedding server, GenAI, RoboFlow, okay, Ollama embeddings, everything you can use. Okay, everything you can use with this ChromaDB. Now you can see some framework integration, like it can also support LangChain, Llama Index, then BrainTrust, LLM tree, okay, then Streamlit, HighStack, OpenLit. So these are the framework also you can connect. Okay, that means it has actually all the integration. If you are using different framework, different let's say large language model, different platform, everything it can support. Okay, so as of now we saw like how we can use with the help of LangChain. Going forward, we'll be also learning how we can use with the help of Llama Index and so on, right? So yes guys, this is all about from this video. In the next video, we'll be learning another amazing vector database called Pinecone. And Pinecone is a cloud-based vector database. That means we can store our embeddings in the cloud platform. As I already told you, Pinecone is a cloud-based vector DB. That means you can store your embeddings to the cloud. So if you want to use Pinecone, so search for actually Pinecone in the Google. So Pinecone. So you will get the first website. Just try to open it up and make sure you create one account. Okay, you just need to create one account inside this website. So for this, you just do the sign up operation. So with the help of your Google account, you can create one account. So once you have the account, just try to do the login. So I already have the account, so I'll just try to do the login here. So once you have logged in guys, you will get this kinds of dashboard. So guys, now let's try to see how we can use this Pinecone vector database to store our embeddings. So guys, what I've done, I already recorded one video previously on this Pinecone, the detailed video, how to use this Pinecone and all. So I'll add this video here. So this video will give you the entire idea how we can use this Pinecone with the LangChain and all. So guys, as you can see, recently they have updated their dashboard, but previously it was actually different kinds of dashboard. But see, functionality wise, it is same. You have to use as it is. But somehow actually they have updated some kinds of actually dashboard. You can see previously this index was like out. That means there was a option called index, directly create index option was there. But they have actually created this index now inside databases. Okay, see inside databases now there is an index option. So guys, this Pinecone is not a free vector database. For this actually you have to take the subscription. But if you are creating, let's say, new account for the first time, here you will get actually a free actually some storage. That means 2 GB storage you will get. That means you can only create one index there. That means one cluster you can create. So if I click on the create index, you will see I can only create one index. And whenever you are creating free index, make sure you are selecting Google Cloud. Okay, not any other cloud. Otherwise, actually it will ask for the charge. See, I already occupied my, let's say, free plan. Now if I click here, see, it will ask for the upgrade. That means I have to upgrade with their, let's say, subscription. I already utilized the free plan, but for you actually will see the free plan option is there because you have created the new account. But for me, I already use this account. Okay, that's why it is showing I don't have any free plan right now. Fine. So make sure guys, you just try to create a new account and try to use this Pinecone. And to create the API key guys, just click on the API key and here you can create the API key. Okay, and this API key will help you to connect with your this Pinecone server. Okay, from your Python code. Now let's try to see how we can use this Pinecone vector database with our LangChain. And guys, one thing, whenever you're installing Pinecone client, make sure you're installing 2.2.4. Okay, this particular version, because whenever I was using this Pinecone, that time actually this version was the stable version. And try to use this version, guys, because this version will help you a lot, because it is having like very easy syntax to store the embeddings to the Pinecone server. So make sure you're installing this 2.2.4 version. So let's try to see how we can use this Pinecone right now. First of all, you need to install some required packages. So just let me write down the comments here. So I'll be installing, these are the packages. So I'll be installing something called LangChain, then Pinecone client. Okay, so if you want to use this Pinecone vector DB, so you need to install this package called Pinecone client, and this is the Python package, and it will help you to connect with this Pinecone. Okay, then I also need PyPDF library, because here I'm going to load PDF data. So previously I showed like how to load TXT data. Now I will show you like how to load PDF data. So I'll show you like all kinds of data, like how to load and all. Okay, so that's why I need to install. These are the packages. So let me install. So guys, as you can see, my installation is done. Now I'll take some new cell, and here I also need OpenAI and tick token. Okay, I think you already saw from my previous demo. So OpenAI is also needed, because I'm going to use OpenAI embedding, and as well as this tick token, because I'm going to use OpenAI embedding. So tick token is the dependency there. Now installation is done. Now let's import some of the libraries here. So here I'm going to import, these are the libraries, and I think you are already familiar with these are the libraries, why I'm loading and all. I also need something called operating system. So I need this PyPDF reader loader, because here I'm going to read like PDF data. So for this, actually I need to load this one from documents loader, but previously I was loading like text loader. Okay, so this is the difference. Then recursive character text splitter means like you want to make your data as a chunks, because I told you why this chunks is required and all. So that's why this is needed. And OpenAI embedding I will be using, and OpenAI LLM model, that means GPT 3.5 turbo. So for this, actually I'm using this OpenAI LLM. Then from LangChain I'm also going and here from LangChain I'm also importing like vector store, which is nothing but my Pinecone, but previously I was loading my ChromaDB. And retrieval QA means like you can also make some question answer, okay, on top of your data you have stored in the vector database. I think I was discussing, okay, with the help of this chain. Then you can also import something called prompt template. Basically you can give your custom prompt here. So this is also possible. Okay, I'll show you one demo here. So let's import these at the library. So first of all, here what I will do, I will create one folder. So let me first of all give one title like load data. So first of all, I'm going to create one folder here called PDFs. So inside that I will download some of the PDFs I have in my Google Drive. So this is the code to download anything from the Google Drive. So here if you see in Google Drive, you will see this ID, okay, of any kinds of file. Otherwise you can download it and manually upload it inside. Okay, it is also fine, but I'm just downloading. So I have one yellow V7 paper in my Google Drive, and also I downloaded one resume, okay, like from Google itself. I've downloaded one resume so the name of the resume is like Rachel Gree CV. Okay, so this is the resume I've downloaded. So these two files I'm going to download inside my PDF folder. And with the help of this gdown package, you can download anything from the Google Drive. Now if I refresh and if I show you my PDF, so see, these are my data are available inside that. Okay, now what I will do, first of all I need to extract the text from the PDF. So for this let me give one title here. So how to extract the text from the PDF. So this is the code. You need to take the help from PyPDF directory loader, and here you just need to provide the path of the PDF file you have. So this is my path like PDF. So here I'm giving the path, and once you have given the path, you just need to call this load function and it will automatically load the data. So let me show you. So it has loaded my data. Now if I print my data, you will be able to see my data. See guys, all of the data has been extracted. Okay, now what I need to do, I need to convert it to chunks, because I can't directly convert it to my vector, because input size might be vary, because I told you whenever you are using a large language model, so it has one input size. Okay, so you always need to take care of the input size. So that's why we need to create as a chunks. So to create the chunks, so this is the code, I think you remember. So I'll be just calling this recursive character text splitter, and here you need to give chunk size and chunks overlap. Okay, I think I have already discussed what is chunk size and chunk overlap. Then simply I'll just execute it. Then I will apply on top of my data. Okay, so this is my entire data, and here I'm passing this in my text splitter object. Okay, now it will give me the text chunks. Now let me execute and show you. So guys, this is my text chunks. Okay, see, this is another chunks, this is another chunks. So let me see like how many chunks I got here. So length text chunks. So I got around 168 chunks here. Okay, now if you want to see any specific chunks, so you can also print. Let's say I want to see number 1. You can also print for other. This is number 2. Okay, now here if you read it carefully, you will be able to see like also some chunks overlap is also there, like some text is coming from the previous chunks also. Okay, now guys, you can also print like third one as well. Now guys, first of all I need to download the embedding. So download the embedding, first of all you need to set up the environment. You need to first of all what you need to do, you need to set up your OpenAI API key. Okay, so I think you remember I can use my previous notebook. So in my previous notebook I already created this API key and I already set up my environment. I'll just copy this code and here I will paste it at. Okay, now I'll set my OpenAI API key. So let me set it. Yeah, now first of all I need to download the embeddings. So this is the code for it. So it will give you the embeddings, like OpenAI embeddings. Now first of all let me test one thing here. So what I can do, I'll just call my embedding. Like I just want to show you like what is the length of the vector it will generate. Okay, so I'll just call embedding.embed query, and here if you pass any word, let's say I will give hello. Okay, now if I execute, you will able to see the vector. Okay, see, this is the representation of the hello. Okay, and this is the vector. Okay, this is the vector representation, numerical representation. So I'll store it in a variable called result. Okay, now if I show you the length of this result, so let me see the vector length. Yeah, so by default actually if you are using OpenAI embedding, so the each vector length would be 1536. Let's say if I give any word here, let's say I'll give something called good. Okay, let's say good. If I give good, so you will see the length would be same. Okay, now if I give, let's say anything like I can give hello, or let's say how are you, how are you. So again the length would be same. See, length would be same. So basically what is happening, I think I was discussing this thing in my theoretical lecture. So whenever it is like trying to generate these kinds of vectors, okay, so it was following this approach. Basically it was creating some features. Okay, so with the help of the features actually it was generating these kinds of vector. So basically what is happening, so the sentence you have given, so this sentence is representing in this dimension actually 1536. Okay, this is the dimension of the sentence. Okay, and it is representing in that. Here I was referring this word by word, but you can refer as a sentence by sentence. So basically this king is appearing in this dimension actually 1 2 3 4 5 6. Okay, 6 feature we have created. So this was the 6th dimension. Okay, 6th dimension, this king was representing there. Okay, but whenever I'm using OpenAI, so I have written like how are you there. Okay, how are you is representing with the help of 1590 sorry 1536 vector. Okay, this is the dimension. Okay, if I plot it, okay, so this should be the dimension and this is the representation of the how are you. Okay, I think you are getting like how it is generating this vector and all. Okay, so if you give any sentence here, so this should be the length. So now I need to store these are the vectors. Okay, like I will apply this vectors embedding on top of my data. I have created the chunks. Then I will store it on in my Pinecone vector database. So for this, first of all, I need to initialize the Pinecone. So let me initialize it. So for this, first of all, what you need to do, you need to collect some Pinecone credential. So you need to collect like Pinecone API key and Pinecone environment. Okay, so how to collect it? So just go to Pinecone, and this is my dashboard. And here I already told you how to collect this API key. Just create a API key and try to just copy. And here just replace your value. Okay, no need to use my value because I'll be removing my keys. So you need to use your value. Okay, so just try to replace this value. Okay, then you need to also collect something called Pinecone API environment. Okay, so how to collect it? So here, if I go to now, just click on index. So here you just need to create one index here. So first of all, it would be empty, and here you just only can create one index because it's a free one I am using. Okay, now I'll just click on create index and need to give the name. So here I'm using, let's say this is my test, or you can give any name. I'll give test index, and here you just need to specify the dimension of the vector. Okay, now here I already showed you. So this is the dimension of my each vector. Okay, so this is the dimension. I'll copy this value, and here I'll just write it. And you can also select the metrics, like what kinds of metric you want to use to retrieve your similar kinds of vector. Okay, so by default it is cosine. You can also use Euclidean and dot product, but cosine is a little bit fast. Okay, because if it calculating cosine distance, okay, so it will be like a little bit fast, okay, to calculate, because I was already discussing, right? If I show you that graph, so see, if I want to calculate cosine similarity within these two vector, so it will just create one angle here and it will give me the cosine similarity score. But if I'm using Euclidean distance, so it will just calculate with respect to all the data points I have here. Okay, so that's why cosine is first in this case. Okay, so I'll be using cosine metric. Now here, this is the default pod you need to select, and this is the free plan I already told you. Now I'll just create the index. Now see guys, it is initializing, so you need to wait for some times. Once it is done, so it will give you this green status. Okay, now see guys, it has created. Now here you will see the environment name. Okay, and this is the GCP provider. So basically this cluster has been created in the GCP cloud, and this is the region, and this is the environment name. So this parameter you can set if you are taking their paid subscription, but by default if you are using free one, so they will assign these kinds of provider and region. Okay, now I'll copy this environment name, and here I'll just need to replace. Okay, so for me I have already replaced, which is nothing but GCP starter. Okay, now let me just quickly set this environment variables, okay, inside my environment. Now here I will initialize my Pinecone. So if you visit Pinecone documentation, so they have given this code, like that's how you need to initialize Pinecone. So here you just need to provide this API key. So here is my API key. It will read from my environment, and here is my Pinecone API environment. So this is the environment. So it will automatically read it and it will initialize that. Okay. And here you also need to provide the index name. So this is my index name we have created called test. But if you are creating any other name, you can give the same name here. Now let me just quickly initialize this Pinecone. Yeah, so it has initialized. Now what I need to do, I need to create embeddings from my chunks. So let me first of all comment. So to create the embeddings from the chunks, so this is the particular code you need to execute. So first of all, here, whatever embedding I'll be generating, okay, so I'll store it in my Pinecone. That's why I'm just writing Pinecone from text. Okay, and here I've just written one list comprehension. Okay, I think you know list comprehension in Python. Okay, so basically the chunks, text chunks I have, so I'm just reading one by one. Then I'm just reading the page content. Okay, then this is my embedding object, I think you remember. So this is my embedding object, and I'm also passing my embedding, okay, embedding objects, and also I'm giving my index name. Okay, that means this is the index name. So this Pinecone client will automatically take it, and it will automatically convert your chunks to embedding with the help of this embedding objects, and it will store inside this index name. That means this index. Okay, inside this index it will store all of my vector. Okay, and it will give you one object called docsars. Okay, now let me just quickly execute and show you what will happen. See guys, it is taking all of my chunks one by one, and it has converted to vectors, and it has stored inside the Pinecone cluster. Now if I go to my Pinecone cluster, and here if I refresh this page, so guys, as you can see, I refreshed my page, and now I am able to see all of the vector here. If you see, if you just click on browsers, So here is the vector, okay. And first of all, it will show you the, like top 50 vector here. If you see, this is the representation. So this is the text, and on top of that, actually, this is my vector, okay, I'm getting. So you can also copy the vector and you can also see, okay. And the length of the vector is this one, actually, I think you remember, 1536, okay. This is the length. And this is the beauty of this cloud vector db. You can see your vector here, like how this vector has been created and what is the text with respect to that. And you can also see the scores, okay, like what is the scores with respect to these vectors. Like this is the distance, actually, okay. That's how it create the index, okay. I think I was also talking about like index in vector database, right? Indexes in vector database. This is the score, okay. Using this score, actually, it try to figure out the similar kinds of vector whenever you search any query, right? So this is the beauty of this vector, and I love this Pinecone one because it looks very easy, and it's like very beautiful interface it provides, okay. And you can also see the second page, and you can see all kinds of vector here. Even you can also change the parameter. Let's say I want to see top 100 vector here. So if I just search the query, so it will give me all the 100, okay, 100 vector here, okay. So yes guys, and you can also see the metrics, like how many times you are raising the request and all. So it will give you all kinds of log here, like if any request is failed, so it will give the error logs and all, everything it will give you, okay. So yes, so this is the simple interface of my this Pinecone, and vector counts is 168, because if I show you my chunks, okay, my chunk size was 168. So that's why you are able to see this vector count is 168, because I had 168 chunks. So with respect to that, this vector has been created, okay. So yes guys, this is all about my Pinecone one. Now we are able to successfully store our data here, and this is the cosine, and this is the dimension, and all kinds of host and provider you can see here. Now let me show you like how to query out on top of your vector and all. So for this, what you can do, you can use something called similarity search. But before that, let's say if you have already one cluster here, okay. So what you can do, you can load this cluster directly instead of storing that vector again and again. So this is the code for it. So let's say I have already one cluster. So you just need to give the index name, which is nothing but, let's say, test. And here you also need to give the embedding. Like here I'm using OpenAI embedding. So here I'm giving the embedding objects. Now if you execute, it will automatically load this index. Okay, it will automatically load. These are the vector here. Now see, it has loaded this vector. Now on top of that, you can perform similarity score operation. Now here, let's say I will ask one query. Let's say I have one YOLO V7 paper here. I think you saw that. So here I'm raising one query like YOLO V7 outperform which model, okay? Like we have lots of YOLO model, right? So from them, actually YOLO V7 performs actually which model. So this is the query I'm asking. So now this query, I will give it to my doc source. This doc source, this is the object, okay. Basically it will have all the like you can say vector objects and all, okay. So here I'm going so here actually I can directly ask the query. So it has one function called similarity search, okay. So inside that, you just need to pass the query and you need to set the k, okay. I think you know what is k. So k means like how many output you want to get, okay, from your search results, okay. So it will give me 3 results, okay. Now if I execute and show you, query is not defined because I haven't executed. Now let me show you. See, so it will give me a top similar 3 output. See, this is the 3 output it has given, but again it's not readable. So what you can do, you can take the help from LLM. So LLM, if you give this query and this output to the LLM will try to understand this query and the output, and it will give you the best answer, okay, from them. So here let's ask this query to my LLM. So I'll first of all initialize my LLM, and here I'll be using a retrieval question answer from LangChain. I think you remember I was also using, and chain type is stuff, and here I'm just giving this retriever objects as my doc source, okay, and as retriever, okay. You need to give it like that. Then it will consider you are it will you want to ask any kinds of question, okay, and you want to get the answer. Now let me initialize this question answer object. Now you can ask the query here. So I'll ask the same query. So this is my query, and I will ask it to my LLM model. So I'll just initialize QA.run, and if I give the query, so it will give me the answer. See guys, YOLO V7 outperforms YOLO V5, L6, YOLO X, YOLO EX. Okay, so these are the model actually. It outperforms. Okay, see, it is giving the correct answer. Now I'm not getting this kinds of answer. Okay, I'm getting my relevant answer. Now I have one resume. I think you know. Okay, I have one resume also. Richard Gray CV. So let's ask some query from this resume also. So here is one question I prepared called Richard's Green experience. Okay, like what is her experience? Okay, so see, it will automatically give you that experience as well. This is the power of LLM. See, it's giving Richard Green has a PhD in English from the University of. It is giving like some more information about Richard Green, but it's pretty good, right? Yeah. So you can ask any kinds of questions. So you can also create one while loop here. So let me show you how to create while loop. So this is the while loop I have created, and here I'm taking the user prompt. So here you need to import one library called sys. Basically, whenever you are you want to exit, so you can exit it also. So this is like input I'm taking from the user, and if user is giving like exit, so it will exit. Okay, this code would be exit, and if it is not, then it will take the query and it will return you the answer. Okay, now let me show you. So if I ask like what is YOLO V7, now if I press enter, so it will give me the answer. See, YOLO V7 is a real-time object detection which surpassed all known object detection in bound speed and accuracy. Okay, it's giving the correct answer. Now let's ask any query. Tell me about Rachel Green. Yeah, I think Rachel spelling is not correct. I think it should be E. Now let me ask. See, it's giving the correct answer. Okay, now if I press, let's say, exit, now it should exit the, yeah. Okay guys, I think you saw the entire like demo how we can use the Pinecone, and you got the clear-cut idea. Now in the next video, we'll be learning another amazing vector database called Weaviate. Weaviate is also a like you can say cloud-based vector database. There also you can create a cluster and you can store your embeddings. So if you search Weaviate in Google, you will get this documentation. So here they have already mentioned like how to connect this Weaviate with the LangChain and all, everything they have given, all the integration and all, how to install, okay, how to configure, everything they have given. So guys, what I've done, I prepared one notebook. This notebook will give you the entire understanding like how we can use this Weaviate vector database. Now this is the official website of the Weaviate, Weaviate.io. So here you need to create one account first of all. Make sure you have created the account, and after creating the account, actually you will get free credits. With the free credits, you can only create one cluster. The same way you did for the Pinecone as well, right? And again, it's a paid one, guys. You have to pay if you want to use their, let's say, advanced, let's say, I mean, functionality. You have to pay for that. So here we'll be only exploring the, let's say, free one, the free tier one, because free tier one is enough for learning. Fine. Later on, if you need it, you can also upgrade your subscription. So if you want to create the account, just click on try now button. So you will see they will ask for the email and password. With that, actually, you can create your account and you can log in with this Weaviate. So guys, now let's try to see the practical how we can use this Weaviate vector database. So here, first of all, you need to install some of the libraries. So these are the libraries are common. So guys, here now I'm using something called Weaviate. So this is the like Python package like Weaviate client. So you need to install this package to connect with your Weaviate. Okay, Weaviate cloud database. Now let me just quickly set up them. Now guys, what to do, you need to collect some of the credentials. So these are the credentials are required. So first of all, I need my OpenAI API key. Then I need my Weaviate API key and Weaviate cluster. Okay, cluster URL. So this three thing actually I need. So I think we already created my OpenAI API key. Just try to copy from my previous notebook. So here is my API key. So I'll just copy. And here I will just try to paste it. Okay. Now let's see like how we can collect this Weaviate API key. So for this, just visit your Weaviate dashboard, and here just try to create one cluster. Just click on create cluster. Okay, you need to give the cluster name. So let's give any name. So I'll give test. Okay, so you can give any name. So everything will remain same because this is a free one, and it will expire in 21 days because this is the free version, free tier I'm using. Okay, but if you want to use for your production grade applications, at that time you can take the subscription. Okay, now just try to create the cluster. So it will take some time. Once it is ready, so it will give you the status message. And guys, if you see, Web8 also support these kinds of client like Python client, Java client, CLI, TypeScript, then Go. So it has actually multiple client support. So like those are working in Java and all, so you can also use it. Now guys, see, my Web8 cluster is ready. Now if I click on detail, now here it should give me that detail of my cluster. Now here, first of all, I need to copy this cluster URL. Okay, just copy this cluster URL here. From here you can also copy. Now let's go back to my Web8, and here you need to paste it. Oh sorry, this is my API, so I need to paste it here. This is my cluster URL. Okay, now I also need to copy the API. So here is the API option. Just click here, and this is the API key. Just try to copy and don't share. I'll delete it after this recording, so that's why I'm sharing. And I'll just paste it here. Okay, now I got my 3 credentials. Now let me execute them. Okay, so first of all, I need to read my data. So let me read the data. So here, first of all, I will create one directory called mkdirs data. Okay, now data folder has been created. Now inside that I will upload one. PDF file I have here. So this is the YOLO paper, actually YOLO related content. So you can download any kinds of PDF and you can upload here. No issue with that. You can either use text data, okay, doc data. It's up to you. So guys, as you can see, my PDF has been uploaded here. Now what I will do, I'll just try to load this PDF, okay, and I'll just extract that text from it. So let me show you like how this PDF will look like. So guys, see, this is the YOLO like presentation. Okay, so I have downloaded as PDF. I'll just execute this particular code. So here I'm giving the data directory and I'm telling just load the PDF file. Okay, then I'm loading the data. Now let me load. So it's giving one error. It's telling unstructured package not found. Please install it with pip install unstructured. Okay, so what is happening actually? So if you see here, I have downloaded this Google like you can say slide. Okay, Google slide as PDF. That's why it is considering as unstructured PDF. Okay, so that's why we need to install one package called unstructured PDF. So let me install it. So this is the command to install. But if you are having like PDF, like very simple PDF, so you don't need to install it. Okay, so this is for like unstructured PDF. So if you have any complex PDF, so you need to install this package. So previously I was using like paper and all. Okay, that's why it was simple PDF, but now I'm using like Google slide PDF. That's why it's giving this error. And it's pretty good. Like it will tell you like what are the packages you need to install and all. So it will give you the message as well. So guys, it's done. Now it's telling just restart the runtime. So let's restart our runtime. Okay, now let me execute this code. Now it is extracting all the text from this PDF. You can also upload multiple PDF here. It's up to you, but I have already added one PDF. I just want to show you the quick demo. Done. Now let me show you the data. So guys, this is the entire data I got from my PDF. Okay, now I need to apply something called text splitting. I think you remember. I need to convert it to chunks. So let's convert it. So recursive character text splitter. Okay, I'm importing from LangChain, and this is the chunk size and chunks overlap. You can give any number here. So let me just do it quickly. Now I got my chunks. Okay, see, this is my chunks, and also let me see the length. See, all the things are common only. We are just changing the database client. Okay, like I'm using ChromaDB, Pinecone, and Weaviate. So just client is changing, but steps are same. I think you are getting. Now I need to convert to embeddings. So let me just comment it out. So here I'm going to use OpenAI embedding. OpenAI embedding, and here you need to pass the OpenAI API key. If you're not passing, it's fine. You need to add inside the environment variable. So previously we added, if you see here, environment variable, but here I'm not adding environment variable. If you're not adding inside environment variable, you can directly pass them. Okay, that will also work. Okay, it's giving error. OpenAI is not defined because we have restarted the runtime. So I need to execute this cell again. Now I think it should work. Now here I'll be initializing my Weaviate vector database. So if you visit Weaviate documentation, there is the documentation, and here they have given the installation guideline, then configuration, then what is the schema, libraries, everything they have explained. Okay, so you can visit the documentation and you can get all the information. But here I already gone through the documentation and I prepared this notebook. So this is the code actually you need to write to initialize your Weaviate actually. That's why actually I like Pinecone one, because Pinecone looks easy to me, because what I feel like Pinecone is like more easy, and it's like more easy to understand and like more clear. But if you're using Weaviate, so you need to write some extra code it. Okay, but it's completely fine. Okay, no issue. You can use it. I will share my notebook. You can use this notebook as it is. So here I'm just first of all importing Weaviate from LangChain. You can also import directly. It is also fine. Now here you just so first of all you just need to connect with your Weaviate cluster. Okay, this cluster we have created here. I think you remember this is the cluster. So to connect with the cluster, you need to give the API key, Weaviate API key, and I think you know we already collected the Weaviate API key here, and I stored in the variable. Okay, then I also need collected the cluster URL. Okay, both I have collected. Now cluster URL you also need to give. Then you need to initialize the client, and inside that you need to give the cluster URL and as well as the OpenAI API key also, because using the OpenAI API key, it will use the OpenAI embedding. Okay, whenever it will convert your data to vector embedding, so it will use that OpenAI embedding. Okay, so that's why you need to give the OpenAI API key here. Now I also need to give something called authentication configuration. So this is the authentication configuration, which is nothing but my API key, Weaviate API key, and this is the startup period. These are some default parameter you need to give, and let's execute. Okay, now if you want to check it whether this client is ready or not, so this is the code for it. So is ready. So now it is true. That means my client is ready. Now it is connected with my Weaviate client. Now Weaviate is telling you need to prepare something called schema. Okay, here they have given one client schema. So if you visit this client libraries, okay, so here if you see example client schema, so you also need to define some schema here. Schema is nothing but it just it kinds of configuration it will take, okay, as an input. Like you can change the configuration with the help of code. So that's why these are the things they are giving. But if you're not able to get it, okay, it's completely fine. So you just need to give this schema and it will come on for every experiment you'll be doing. So this is the complete schema, guys. Okay, so client schema detail. First of all, if it has any schema, it will delete, then it will add this schema. So here you can give any name. Okay, so I have given chatbot here. Then here you can give any description. Then what are the vector actually model you are using, you can give the name here. So in OpenAI actually you have ADA model. Okay, so here I'm using ADA model. I think you remember. If I print my embedding, so here I was using something called ADA model. Okay, as you can see here I was using something called text ADA embedding ADA model. That's why you can also give the name, and these are some description you can give, and after that you can create this schema and you can create your client. Okay, now this is the code, so you can execute. And this thing is not required in Pinecone. So Pinecone can handle these are the thing automatically, but in Weaviate you need to provide. That's why I personally like Pinecone. Okay, now once it is done, you need to initialize the vector store. Okay, so now this code will initialize the vector. So what it will do, basically it will take your documents. Okay, I think you remember we have created the documents. Okay, we have created a cluster, and from this cluster, with the help of this embedding, we are just trying to generating the vector and storing inside our Waviate. Okay, now let me execute and show you. Now see guys, now if I go to my Waviate and refresh, now it hasn't updated yet. So after some times you will see it will update, like how many embeddings had generated. Okay, then how many times you have you can say did the request, everything it will show you here. Okay, so all the information actually it will give you, and these are the, and guys, these are the embedding model are available by default with this Waviate, so you can use any of them, it's completely fine. But we are using this ADA model, OpenAI generative model. Okay, so yeah. So guys, usually it takes some time, around 5 to 6 minutes. After that, you will able to see all the update here. So in between, what I can do, I can show you the other step. Now we have successfully stored our embeddings. Now let me just do the similarity measurement. That means similarity charts. So here, first of all, I will ask one query called what is YOLO, because this is the YOLO related content. And here I'm initializing this similarity charts. Okay, because the vector store this is my object, and on top of that I'm just writing similarity charts. Here I'm giving the query, and top k, that means how many output you want to get. So here I'm given 20, you can give any number. Now it will return like 20 results. Okay, 20 similar kinds of results. See, okay, but I can't actually take the answer. So what I can give, I can give one chain with the help of LangChain. So here there is another parameter called question answering. Okay, load QA chain. You can also use this chain. Otherwise, you can also use retrieve QA chain. Okay, that is also fine. Now here I'm going to use OpenAI LLM. Now I'll define my chain, and here I need to pass my OpenAI API key, and this is the chain type. And temperature means like if temperature is 0, so your model would be like more you can say stick to the answer, like it won't be giving any randomness. And if you're changing the temperature to close to 1, so it will give some random output as well. Okay, so this parameter you can change. I think if you have learned like LLM, so I think you know this parameter and all. Okay, so these are like basics thing, okay, in LLM. Now let me define my chain. Now here I will ask this query. So chain.run input documents. So this is my documents. This is my entire documents I'm giving. Okay, the documents I have, and see, this is the documents. That means I got all the answer, right? 20 answer, and from this 20 answer I want my query. That means the query I'm asking, which is nothing but what is YOLO. So now with the help of my LLM, I will get my authentic answer. See, YOLO is an algorithm for object detection that is unified, real-time, and has higher accuracy. It is presented by Shivang Singh, and this is the date of the publication. Okay, so yes, I'm getting my output and all. So now you can ask any kinds of question about YOLO and all. Okay, I think you got it. Like I already showed you multiple times. You can either create one while loop, and you can ask many question here. All right, guys, I think everything is clear now. How we can use this Waviate vector database. So we have learned different vector database, guys, so far. Now we'll be using all of them to implement different like GenAI application. If you don't know about LangChain is a generative AI framework. With the help of that, we can implement any kinds of generative AI based application with the help of large language model. So I think you already used something called PyTorch and TensorFlow whenever you used to learn deep learning, right? So inside deep learning, we used to implement computer vision project, NLP project. So there we used to use these kinds of framework like PyTorch and TensorFlow. So both are actually deep learning based frameworks. So with the help of that, you can create a neural network, right? That means all the functionality this framework provides to implement any kinds of neural network to, let's say, work with your data, to load your image, everything you can perform there. So similar wise, if you want to work in the field of generative AI, so inside generative AI, if you want to work with the large language model and all, so you have to use this LangChain framework, because LangChain is having all kinds of integration, all kinds of functionality. Okay, so only you just need to learn how we can use this LangChain properly. And with the help of that, how we can access different large language model, and how we can build different kinds of application. I think you saw the ChatGPT, right? ChatGPT, like, it's a very powerful application. So if you, let's say, give any kinds of prompt, that particular prompt actually it will try to remember. Okay, then if you are asking the next prompt, it will also try to remember that prompt because it is using something called memory. Okay, memory inside ChatGPT, and how this memory is utilizing. So this concept is already available inside LangChain. LangChain is also having the memory functionality. So if you use this LangChain to implement this kinds of project, so you can also create a memory, okay, memory for that application, so that if user is giving any kinds of prompt, this prompt would be also remembered by your application. So not only that, actually it provides actually lots of functionality, guys. Unless and until you are not learning about LangChain, so you won't be able to understand. So what I will do, guys, let's quickly start our this practical demo of LangChain, because LangChain is all about practical here, nothing theory is there. So I already prepared one amazing notebook for you, so there I will show you the entire LangChain demo. So guys, as you can see, this is the Colab notebook I prepared. So first of all, let's connect this notebook. And make sure you select GPU, because going forward, actually we'll be using some open source large language model from the Hugging Face itself. And to use that one, you need a GPU based machine. Okay, so make sure you selected the GPU. If you're selecting CPU, it's completely fine. It will also work, but the execution time would be a little bit high. Okay, that is the thing. Now let me cancel. Now, if you want to see the official GitHub of LangChain, guys, this is so you can see this is the official GitHub of the LangChain. Okay, see, it's like very active research. The last commit was 3 hours ago only. Okay, now we can see they have given all the, let's say, tutorial how we can install and how we can access let's say different services of the LangChain. Everything they have given. Apart from that, see, they are having actually a very huge community. That means these are the communities supporting this library a lot. That means if anything is going wrong in this library, they are let's instantly solving that let's say issue. Even they're also upgrading this framework day by day. Now, apart from that, it is also having one beautiful documentation. So let me show you guys. This is the documentation link. If you just search LangChain documentation on Google, you will see this documentation. Now see, this is the entire documentation they are having. Okay, now see, different things they have developed. They have also developed ecosystem like LangSmith, LangGraph. We'll be also discussing about LangSmith and LangGraph. No need to worry. First of all, let's try to understand the fundamental of LangChain, like how we can install the LangChain, how we can integrate with different let's say platform. Like you can see, it is having different integration. Let me show you. So if I open the third-party integration, see, it supports Anthropic, then AWS, Google, Hugging Face, Microsoft, OpenAI, and many more. Okay, many more. See, all the different cloud GenAI service it is also support. All the different let's say large language model platform it is support. Even you can also integrate with Hugging Face. That means whatever Hugging Face model I think I showed you now, I think you remember, all kinds of open source large language model is available inside Hugging Face. You can also easily use these are the model with the help of LangChain. And always try to remember, guys, LangChain doesn't have any kinds of large language model. Okay, LangChain is just a framework. It's just a framework to work with the generative AI based application with the help of large language model. Large language model wise, it will connect with different platforms. Let's say Hugging Face, let's say OpenAI, let's say AWS, let's say you can see different integration it is there. Let's say Microsoft. Okay, so those who actually provides these kinds of large language model, okay, so it can connect with those platform. This is the idea only. Got it? So it's just a framework. You can see they have also written LangChain is a framework for developing application powered by large language model LLM. Okay, I hope it is clear. Now see, they have written so many things. So what I did, guys, I just prepared one amazing notebook. So this notebook will give you the comprehensive idea how we can install and how we can use this LangChain. I think this is enough for you, okay, to learn about LangChain. Now see, this is the overview. So these are the things actually we'll be covering inside LangChain, like installation. We'll be learning about how we can like access different large language model. We'll be learning about prompt template, chains, agents and tool, memory, document loader, and indexes. Okay, so these are the things we'll be learning. Apart from that, we'll be learning some more advanced, let's say, technique. Like we'll be learning about ecosystem like LangSmith, LangGraph. Okay, these are the things also we'll be trying to cover. Now let's see how we can install the LangChain. So this is the command, guys, to install the LangChain. Just right pip install LangChain, and with that you need to install another package called LangChain Community. Now let me install the LangChain. Okay, so after installing, I just need to set up some environment. Like I need to set up my OpenAI API key as well as the Hugging Face API token. Okay, why? Because here I'll show you how we can use OpenAI. Okay, OpenAI large language model. If you want to use, that's any kinds of commercial model, how we can access it. Even I will also show you how we can access any kinds of open source large language model from the Hugging Face, let's say, hub. Okay, so for this I need to collect this authentication API. I think you know, or we have already generated one OpenAI API key. So see here, I have already written my OpenAI API key. So you can also write your OpenAPI key, and you need to also give the Hugging Face API token. And where you will get the Hugging Face API token, go to the Hugging Face platform, click on the profile, go to the settings. Now left hand side you will see access tokens. Now you need to create a token. For me, I already created the token, guys. You can see LangChain. Now if you want to create, just create a token, give the name. Let's say I'll give test. Okay, after that give the read permission and create the token. Now copy this token and try to mention it here. Okay, I hope it is clear. Now let me delete. I think I already created, so I don't need it. I will delete it. Okay, this token. So my token name is LangChain. You can give any kinds of name, it's up to you. Now let me set, these are the tokens inside my environment. Okay, it is giving one error because I have to initialize the operating system package first of all. Then let me set inside my environment variable. Okay, now what will happen whenever you will be using LangChain, it will automatically load these are the API key from the environment itself. Okay, you don't need to manually set that. This is the idea. Now we'll be learning about how we can use any kinds of large language model with the help of LangChain. So I think we saw we are having like two kinds of large language model. One is like commercial model, one is like open source large language model. Okay, commercial wise, we already saw the entire OpenAI platform. We are having GPT based model, and the open source wise, we are having this Hugging Face model. That means we are having, let's say, Llama model, we are having Mistral model, Falcon model, like different models are available. Okay, in the Hugging Face hub, if you see, okay, there are thousands of like large language models are available. I think I showed you one platform, OpenLLM. Okay, it should be OpenLLM GitHub. Now list of all the OpenLLM. See, all kinds of large language model you can see, and these are actually open source large language model. Fine. Now, first of all, let's try to see how we can access actually OpenAI large language model. See, whenever I think I showed you the OpenAI platform and I showed you the demo of the, let's say, model, like if I want to access this model, if I want to give any kinds of prompt, so how we can do it. See, this OpenAI is already integrated inside LangChain. So I think I showed you the integration now. So this open source integration, just open it up. Now see, OpenAI is already integrated with LangChain. So you don't need to manually, so here you don't need to manually use the OpenAI platform like the way we used previously, like chat completion API, completion API. No, you don't need to use like that. See, it's the very simple. First of all, install the OpenAI. Then just import from LangChain large language model. I want to use OpenAI. Okay, OpenAI platform. That means OpenAI large language model. Just try to import this particular class. Now here, just try to set the temperature parameter. Okay, temperature parameter. Now, what is temperature parameter? I think you remember. Temperature parameter, it's just a creative actually parameter. Like how much creative you want to be your large language model. You can see if it is 0, close to 0, that means temperature, it means the model is very safe and it is not taking any bits. That means it won't be taking any risk. Okay, it will stick to the output. And if it is close to 1, that means this will be taking risk. It might generate wrong output, but it's like very creative. Okay, I think I already explained this part. Now let me initialize my OpenAI wrapper. Now see, I have already initialized my OpenAI wrapper. Now see, this is my large language model. So guys, whenever you initialize this wrapper, by default, actually it will utilize one model called GPT 3.5 Turbo model. Okay. But if you want to use any other model, you can give the model parameter here. There is a model parameter. With the help of that, you can also give any other model name. Okay, later on, I'll show you how we can change the model. As of now, let's take the default model only. Now, let's say this is my prompt. You can see what would be a good company name for a company that makes colorful socks. Okay, this is the, let's say, my prompt I'm giving to my large language model. Now, let me initialize this prompt. Now, see, if I want to, let's say, generate output, generate the response, I need to call the predict function. LLM.predict. Inside that, I need to give my prompt. Now see, it will give me the answer. Now rainbow threads or vibrant socks company. Okay, so this is suggesting the name of the company. Okay, that makes colorful socks. It's great. Now you can also directly pass this text to the large language model wrapper. So instead of calling the predict, you can also give like that. It will also work. So these are some actually way you can give the input to the large language model. Now see, it is also giving me the name. Now you can see, it has given me this name. Okay, this is the response. Now I can also use something called invoke function. Okay, inside invoke function also you can give the input. It will also work. See, invoke has given some more detailed output. You can see it has suggested me different actually company. I can use this name. That makes actually colorful socks. Okay, it's pretty good. Now let me show you the second example. So I've written the same code, guys. You can see now here I've given another prompt. I want to open a restaurant for a Chinese food. Suggest me a fancy name for this. So now let me give. So it is suggest me Imperial Dragon palace. Okay. Great. Now I can give the input like that also inside LLM object. Now Dragonfire Dining. Okay, great name. Now let me show you the Hugging Face. Okay, Hugging Face model, because see, at the end OpenAI is a chargeable. That means if you're sending any request to the open AI, okay, that means OpenAI model, it will charge you based on the token. So it's at the end there is a cost involvement. But let's say you don't want to spend the money, you don't want to use this kinds of paid model. You can also use open source large language model with the help of LangChain. It is also possible. For this, what you have to do, you have to use Hugging Face app. Okay, because inside Hugging Face, I showed you, we are having lakhs of model. And all the models are open source. Okay, all the models are open source, and these are like large language model from the different organization. You can see from Meta, from Google, okay, from OpenAI. Then we are also having, see, OpenAI also having some kinds of actually free model. They are published in the Hugging Face. You can also use them. Mistral is also there. Different models. See, that many of models are available inside Hugging Face. It's like very huge model, na? Even I also showed you different tasks you can select. Based on that also, you can also select the model. It's up to you. Now let me show you how we can integrate Hugging Face platform and how we can access Hugging Face large language model also. For this, you have to install one library called Hugging Face Hub. So let me install Hugging Face Hub. Because the models are available, it is present inside Hugging Face Hub. Because I already told you now, the model they have published, it is called Hub. Okay, Hub. Inside Hub, actually, these models are present. Now see, I installed the Hugging Face Hub. Now let me import Hugging Face Hub from LangChain. Now see, this is the model actually I want to use. So I've already provided the link. Let me open. So this is called actually Flan T5 model. This is from Google. And this is one of the large language model, guys. You can see, if you are interested, you can go through the documentation. Okay. What can this model can perform and all, everything they have given. They have also given the paper link of the model. Now, if I go to my notebook, now see, here I'm using the large model. See, this is the extra large model and it's like very huge. I don't want to load this model. I want to use some smaller model because here I want to show you the quick demo. That's why. So I'm using this model actually, T5 large model. Let me show you. So this is the model, the same model only, but this is the small variant. This is the small variant and this is the X large variant. Like this is like more bigger than this one. Okay, I hope it is clear. Now, see, if I want to load the LLM object right now, that means large language model, I need to use Hugging Face Hub from LangChain. Inside that, I have to give the repo ID. That means the model you want to use, just copy the repo ID and pass it here. And you have to give some arguments. Okay, you have to give some model arguments. That means that same parameter, I think you remember temperature. What temperature will do? I think I already showed you. This is the creative parameter and the max length. I think you remember inside OpenAI also used to pass the max length. That means how many, let's say, output token you want to get from your large language model. So here I have given 64. Okay, you can increase and decrease as per your requirement. You can also remove this one. Okay, it's completely fine. Because at the end, it won't be charging you. Okay, it's a free model. So you can use as many of length you can. Okay. Now see, this large language model we are using, this is not like very good large language model, but somehow actually just to test, actually I'm using it. Going forward, we'll be using very powerful large language model, like we'll be using Llama model, Mistral model, Falcon model, okay, Jimma model, we'll be using different model. But this is like very basic large language model. Actually, I just wanted to show you as of now. Now, this is the prompt I have given. Translate English to German. This particular sentence. Okay, now see, how old are you? This sentence I want to do the translate operation English to German. And for this, I'm going to use this model. Okay, now let me execute and let me show you the magic. See, this is the output I got. This is the German translation of how are you? And this model actually, it is trying to access with the help of Hugging Face API. Okay, Hugging Face API. That means the token you collected and I think you just set inside environment variable. With the help of that, it is sending the request to the Hugging Face. Hugging Face is returning the answer. Okay, we are accessing through API request right now. Going forward, we'll be also learning how we can download the model as well. And we'll be loading that model with the help of LangChain and we can create a LLM wrapper and we can do the application building. Okay, so I'll also show you this part. No need to worry. As of now, I'm showing you the API access. Okay, if I only want to perform the inference operation, how we can perform it. That is the idea. Now, again, I've given the second example. The same example, I want to open a restaurant for Chinese food. Suggest me a fancy name for this. Again, I've initialized my LLM wrapper with the help of my Hugging Face model. Now, if I give this prompt to my large language model, see, it is giving me Chinese restaurant. So this is not actually creative RIM because I told you now I'm using very basic large language model. That's why. Okay, so yes guys, this is the introduction of LangChain. I think you got it. What is LangChain is and how we can use LangChain exactly. Okay, and it's like very easy to use. Very easy to use. It will, trust me guys, it will make your task very easy. If you're using LangChain, it will make your task very easy. Okay, now in the next video, we'll be learning about something called prompt template. Okay, like how we can create different prompt template and how we can pass to the let's say large language model, okay, with the help of LangChain. So previously I think I showed you how we can use this LangChain to access different large language model. And whenever I was accessing this large language model, that means whenever I was let's say sending my prompt to the large language model, you can see I was giving the complete prompt. Okay, this is the complete prompt actually I was to pass. Let's say this is the prompt: I want to open a restaurant for Chinese food, suggest me a fancy name for this. Now let's say if user needs to change this food, okay, food, let's say category, let's say he wants to, let's say, put Indian food here. So what he has to write again, he has to write the complete prompt, yes or no. That means if I show you, let's say I can copy and I can paste it here. Let's say I will comment this line. Now let's say here, instead of Chinese food, I will give Indian food. Okay, Indian food. Now if I execute, see, it is giving me Indian restaurant. Now let's say if I want to give any other food, let's say I want to give Korean food, I want to give, let's say, Pakistani food, I want to give, let's say, Italian food. So I have to every time write the entire prompt. Okay, but let's say you are creating a complete application. You are creating a complete, let's say, web application, or let's say Streamlit application, or any kinds of application. There you don't want to pass this entire prompt again and again, because if user let's say needs to pass this prompt entirely again and again, so it would be little bit actually, let's say, hard for the user, yes or no. Now see, instead of passing the entire prompt, you can see we can only change this food category. Okay, the food category will only change, otherwise see this prompt will remain same na every time. So that time actually I can do the slight modification here. That means I can create a template of the prompt, and user will only select that part he needs to change here. Okay, this is the idea. Now let me show you how it can be done. So for this actually we'll be using something called prompt template. Okay, now inside LangChain we are having inside LangChain prompts we are having something called prompt template. Now here I've created a prompt template, and here I've given the input variables is equal to cuisine. Now this is the same prompt I have written. You can see I want to open a restaurant for, now you can see in the bracket I have written cuisine. Okay, now this is going to be the input only, and rest of the let's say prompt will remain same. Okay, as per the prompt you have written previously, suggest me a fancy food this. Okay, now here is the prompt template I'm creating. I'm just doing the format operation, and cuisine is equal to Italian. That means user will only give the food category right now. Let's say Italian, Indian, Pakistani, okay, or let's say Bangladeshi, anything they can put here. It's up to them. Now user don't have to write the entire prompt. User will only change the food category here. Got it? So this is called actually prompt template. So whenever we'll be creating any kinds of let's say large language powered application, whenever we'll be creating any kinds of GenAI application, we always need to take care of this particular prompt. Let's say I don't need to pass the entire prompt. Instead of that, what I can give, I can only give the prompt which is required to get my output. Okay, this is the idea. Now see, if I execute this line, now see, it is creating my complete prompt. That means user is giving Italian food. Now see, in the cuisine section it will come the now you can see in the cuisine section it will replace with the Italian. Now if I give, let's say, Indian, now see here it Indian will come. Okay, I think you got it. Now there is another way you can define this prompt template. Now you can write prompt template dot from underscore template. Now this is another prompt I have given. What is the good name for the company that makes? Now you can see product should be the input. Now here you can pass the product name like that. Prompt dot format product is equal to colorful socks, or any other name, let's say cakes, or let's say biscuits, anything you can give here. Now if I execute, see, in the product this input would be replaced. Okay, so this is called actually prompt template inside LangChain, and this is like very powerful concept, guys, because going forward whenever you will be implementing application, this concept will help you a lot. Got it? So yes, this is what I just wanted to show you. In the next video we'll be learning about chains inside LangChain, and with the help of chain actually we'll be integrating this prompt template as well as the large language model, and we'll be again doing the inference operation. And what is the use of prompt template? I already explained. Now see, if I want to use this prompt template with my large language model, so what I have to do, I have to combine my large language model as well as the prompt template I have created. Okay, for this we'll be using something called chains. You can see combine LLMs and prompt in a multi-steps workflows. Okay, to create a multi-step workflows, I have to create a chains. Now let me show you one example. I think then this part would be clear. Let's say first of all I will initialize my large language model wrapper, and here I'm using OpenAI model. Now see, previously I think you remember we learned this prompt template. That means if I want to, let's say, give any kinds of prompt, but I don't need to pass the entire prompt, only I want to pass some specific, let's say, point of that particular prompt. You can see here only I want to change the product name. So for this I created a prompt template, and the product name I've given the colorful socks. Okay, this is my entire prompt. You can see now it will create my entire prompt. So which is the good name for the company that makes colorful socks. That means whatever input you are giving, it will replace it here. Fine. Now, as of now, let me comment this line. Let's say this is the prompt I have created. This is the entire prompt I have created. I think you would remember. Now, if I want to use this prompt, the prompt template I have created with my large language model, I have to use something called LLM chain. And how to import LLM chain? So from langchain.chains, import LLM chain. Now, the first parameter you have to give the large language model. The large language model you have defined, which is nothing but open AI large language model. You can also use open source large language model. You can use Hugging Face large language model as well, the way I showed you. Then you have to give the prompt template. The second parameter is, you can see prompt is equal to prompt. That means the prompt template I have created, this object actually I'm passing here. Then just try to call this function chain.run, and inside that give the input. Let's say whatever input you used to give like that. Instead of giving, you have to give chain.run and give the input. Let's say colorful socks. Now if I execute, see, it will give me the output. See, rainbow threads or chroma shocks, I think. Okay, chroma shocks, actually it is giving me the output. That means now we are able to use our prompt template as well as the let's say LLM. Okay, and for this we are using something called LLM chain. That means first of all, it is creating the entire prompt template. First of all, it is creating the entire prompt template. That means this entire prompt template, if I show you, that means it is first of all creating the entire prompt template, and this prompt actually it is passing to the large language model, and how things are happening with the help of LLM chain. Okay, that's why here I have written with multi-step workflows. That means it is creating a workflow in the backend. It is creating a pipeline. So first of all, it will create the prompt, then this prompt would be passed to the large language model, and these things are handling by the LLM chain. I think you know what is chain, na? Chain means like one, let's say chain would be connected with another one. Okay, that means complete pipeline, complete workflow, sequence of, you can say, chains. Okay, so I think now you got it, what is chains exactly inside LangChain. Now let me show you another example, example 2. So again, I'll initialize my large language model, and see, now here I'm using the second approach. I think, remember, we can also create the prompt template like that. So let's say here input variable is nothing but my cuisine. That means cuisine will only change and rest of the prompt will remain same. Okay, now this is my prompt template. Now if I want to pass this prompt template to my large language model, what I will do, I'll use the LLM chain. Inside LLM chain, I'll first of all give the LLM, then I will pass my prompt template, the prompt template I have created. Now you can see I'm calling chain.run, and here I'm giving the input. Let's say Mexican. I want to see the Mexican. Now here you can see I've given Mexican as an input. That means I want to open a restaurant for the Mexican food. Now if I execute, so it should suggest me some fancy name for this. See, this is the name it has suggested me, El Sabor de Mexico. Okay, the flavor of Mexico. Now if you want to see internally how it is like creating the entire prompt, for this you can activate one parameter called verbose is equal to true. Now see, if I again execute, it will show you, see, internally first of all it will create the complete prompt template. That means here you have given Mexican, so it will first of all create the complete prompt template with the help of Mexican. This prompt template will be passed to my large language model, and large language model will give you the output. Got it? So this is the work of chains. Now this is called actually single chains. Now let's see if you want to create a multiple chain. That means let's say you want to create a chain, and this chain output you want to again pass to another chain. Okay, for this you can use something called multiple chain. Okay, multi-chain. And to use the multi-chain, you have to use something called simple sequence chain. So there is another class inside LangChain chain called simple sequential chain. We'll be using this one. Let me show you one example. Let's say this is my large language model I have defined, and this is the prompt I have created, the first prompt. You can see the same prompt. I want to open a restaurant for the cuisine's food. Suggest me a fancy food name for this. So it will take the cuisine input, and this is the LLM chain I have created. Okay, I think you remember, this is the LLM chain I have created. That means this is my LLM wrapper, and this is my prompt template. Okay, now what I want, whatever, let's say restaurant name actually it will suggest. Okay, whatever restaurant name this prompt will suggest, that means this large language model will suggest. This name again I want to pass to another prompt template. For this I created another prompt template. Now input variable is restaurant name. That means this prompt will give you the restaurant name, yes or no, because here you have given cuisine's food, suggest me a fancy name for this. Okay, now it will give you restaurant name, and this restaurant name I want to utilize, and here I have written another prompt, suggest me some menu item for this restaurant name. That means let's say you have given Indian, let's say food. Now it will give you some Indian restaurant name, and this Indian restaurant name here I will pass, and it will give me some menu item for the Indian restaurant name. Okay, I think you got it, how it is interconnected with each other. This is called actually multiple chain. Okay, now see here I have created another chain. Now if you want to use this both chain, I have to use something called simple sequential chain. Now there is some limitation inside simple sequential chain. I'll tell you what is the limitation. As of now, let me show you the, let's say, example. So you can see I have initialized the simple sequential chain. Inside that chain is equal to, first of all I will give my name chain. You can see, first of all I will give my name chain. That means it will give me the restaurant name. Okay, then I will give my food item chain. That means this particular chain. That means whatever restaurant name I will be getting from this chain, I want to pass to the next chain. Okay, which is nothing but my suggest me some menu items for the restaurant name. Okay, now here is the final code, chain.run. Here I have given the Indian. That means first of all it will go inside that and it will give the output, and this output will go in the next chain. Okay, now it will give me the output. Let me show you. Now see, I have given Indian. Now see, this is the Indian menu I got. That means what is happening? First of all, it is executing this prompt template. Then it is executing this prompt template. Okay, and how it is handling? It is handling by the simple sequential prompt template. That means it is following the sequence. First of all, this sequence will execute. Then this sequence will execute. That's how we can create multiple prompts. Not only 2 prompts, you can create 3, 4, 5, 6, and so on. If you need any kinds of, let's say, application, this is like interconnected with, let's say, previous prompt. Okay, you can create this kinds of sequential prompt. Now I think you got the idea how ChatGPT works. Okay, how ChatGPT works. Let's say how, let's say if you are giving any kinds of input, how it is connected with the previous prompt as well. Okay, they are also using something called this sequential chain in the backend. Okay, chain method they are also using. I think it is clear now. Now the limitation of simple sequential chain is it is only showing you the last output, last chain output. You can see only the menu item. But if I want to also see the previous chain output, what is the output it is giving, for this you have to use something called sequential chain only. Okay, sequential chain, not the simple sequential chain. Okay, this is the difference only. Now let me show you one example. Let's say I have given the same example. So I want to open a restaurant cuisine name. Okay, here I have to pass, and here creating the LLM chain. Okay, now this is the another chain I have created, guys. You can see. So whatever, let's say restaurant name actually I will get from my first chain. So you can see output key, it will return you the restaurant name. So it should be the input for the next chain, which is nothing but my menu. Okay, menu of the restaurant name. Here you given the input is equal to restaurant name, and this is the template. Suggest me the menu of the item for restaurant name, and this is my second actually chain I have created. And what is the output of this chain? The output would be menu item. That means whatever menu actually it will suggest you. Now here I have initialized my sequential chain. Now inside sequential chain I have to pass my chain. First of all I have to give my name chain. That means the first chain I have created. Then I have to give the second chain. Now here you have to specify the input variable. What is the input variable? I think you saw the first input variable is nothing but cuisine. Okay, cuisine should be my input variable. And what with the output variable? Output variable would be the restaurant name as well as the menu item. Okay, restaurant name as well as the menu item. That means both it will show me. Now let me execute and let me show you. See, now I'll call my chain, and here I'll give the input only, which is nothing but Indian. That means cuisine name. Now see, it will give you the output. See, first of all, it will give you the cuisine, then the restaurant name as well as the menu item. That means this prompt, it is giving you the output. This prompt, it is giving you the output. Even the menu item, it is also giving you the output. That means complete output you can see here. So which is not available inside my simple sequential chain. Okay, this is the difference only. I think you got it right now. Got it? So yes, that's how actually we can use chain to interconnect my prompt template with my large language model, and we can easily get any kinds of response from my LLM. Okay, now in the next video we'll be learning about something called agents and tool inside LangChain. So what is agents and tool exactly? Let me show you. See, agents and tools is actually very powerful concept inside LangChain. So it will help you to, let's say, plug in with different kinds of, let's say, tool. Let's say if I give you one example, let's say I have traveled from Dubai to Canada. I type this in ChatGPT. Now give me 2 flight option from Dubai to Canada on September 1, 2024. Now ChatGPT will not be able to give the answer because it has actually knowledge till September 2021. That means after 2021, if you are asking anything to the ChatGPT, it won't be able to give the answer because it doesn't have like the new information regarding 2024. But ChatGPT Plus has Expedia plugin. If we enable this plugin, it will go to the Expedia plugin, and it will try to pull the information about flights, and it will show the information. That means if it is not able to give the answer related to 2024, what it will do, it will try to connect some third-party plugins, third-party API. Okay, and from there actually it will pull the information and it will show you. Let me show you one example. Let's say this is my ChatGPT. Now here, if I give this prompt, what was the GDP of Canada in 2024? Now see, if I give this to the ChatGPT, See, ChatGPT is searching Kannada GPT. See, it is already searching. Okay, it is already searching in the third-party API. Now see, in 2024, now you can see it has given me the answer in 2024. What was the GDP? Okay, in that Kannada. That means it doesn't have the information about, let's say, 2024. What is the Kannada GDP? But it was searching. Okay, it was searching in the third-party API. That means it has some plugins inside that. Okay, so it is happening with the help of this agents only, agents and tool. Okay, with the help of agents and tool, they are doing this kinds of tasks. Now let me show you how you can also perform this agents and tool operation inside LangChain. Let's say you want to create an application, and this application will also be able to give the answer from the newest, actually, let's say information, okay, over the internet. For this, you can connect actually different tools, different plugins. You can connect SARP API. See, this is the SARP API. SARP API is a Google search, actually, let's say API. You can also directly search from the Google. Even you can also connect the Wikipedia. Okay, let me show you one Wikipedia example. Even you can also connect different actually third-party plugins. Okay, there are so many third-party plugins. If you search on Google, you will see different third-party plugins they are using. Okay, you can also connect it to weather. Okay, weather API to get the, let's say, recent weather. It is also possible. Now see, first of all, I will be installing Wikipedia just to show you the demo of the Wikipedia. Now you can see I'm importing these agents from the LangChain. I'm importing agents type, then initialize agents and load tools and all. Then I'm also importing my OpenAI. That means I want to use OpenAI large language model as of now. Now this is my, let's say, LLM wrapper. Okay. Now if you want to define the agents, so you have to define like that, guys. First of all, call this load tools, and inside that, first of all, mention which, let's say, plugins you want to use. I want to use Wikipedia plugins. That means whatever things actually I'll be searching, if it is not available inside my ChatGPT, let's say knowledge base, it will go to the Wikipedia. Okay, it will hit the Wikipedia, and from Wikipedia, actually, it will get the response. Then it will also use something called LLM math tool. And why LLM math tool? Because let's say if you are asking something related GDP, or let's say any kinds of number, any kinds of numerical representation. So for this, actually, this LLM math is required. Okay, they are suggesting if you go to the documentation, you will see that. Then I'm also passing my LLM wrapper, this particular object. Okay, now it will give me the tool. Now here I have to initialize the agents. First of all, give the tool you have created, then give the LLM you have created, as well as the agent type. So this is the agent type you can give, and verbose is equal to true means it will also show you the output. Okay, like what it is executing in the backend. Now just simply search agent.run. What was the GDP of US in 2024? Let's say this is my question. 2024 GDP I want to ask. Okay. Now see, if I execute this program, now see, it has actually connected with my Wikipedia, and it has fetched the information, and this is the final results, guys. You can see the GDP of US in 2024 was 28.269 trillion dollar. Okay, it's great. That means it is also able to get the current information, okay, newest information over from the internet itself. And this is like very powerful tool, guys. Trust me, if you want to implement any kinds of let's say LLM powered application, and you want to integrate this kinds of functionality, you can use this agents. Okay, because ChatGPT is also using agents in the backend. I hope it is clear. Okay, now in the next video we'll be also learning about memory. Let's say I told you, ChatGPT can also remember the previous context. Let's say if I give one let's say message here, give me a code to add 2 numbers in Python. Let's say this is the prompt I have given. Now see, it has given me the code. Now see, it has given me one function, but I don't need the function. I'll just write without function. Now see, it has automatically remembered my previous prompt I have given, and now see, beautifully it has given me the second response. That means it is having some memory, okay, buffer memory in the backend. With the help of that, actually, it is trying to remember my previous context. So we'll be learning this part in the memory part. I think I already showed you one demo of the ChatGPT. ChatGPT can remember my previous, let's say, prompt. That means whatever previous prompt you are giving, it can remember that context, right? So how they're remembering the previous, let's say, prompt and context? Because they're using something called memory. Okay, memory in their application. Now, with the help of LangChain, actually, we can create this memory. So whenever you want to create any kinds of generative AI applications, so definitely you should integrate the memory with that, because people will be asking the question, and your application should remember that particular context. Okay, this is the important things. Now let me show you one demo of the memory. So here I've already written chatbot application like ChatGPT. You will notice it will remember the past information, and how they're remembering the past information. They're using memory. So let me first of all initialize my LLM wrapper. I'm using the OpenAI LLM here. Now, first of all, let me show you, if you are not using like memory, okay, memory, let's say functionality from the LangChain. what will happen? Let's say here I've created a prompt template. The same prompt template, I want to open a restaurant for the cuisines food. Suggest me a fancy name for this. Now see if I create this prompt template, and if I give this prompt template, what I have to do, I have to use LLM chain. Here I'm passing the LLM, and here I'm giving the prompt template. Okay. Now this is the, let's say, input I've given Mexican. So it will give me the output, the restaurant name. So guys, you can see it has suggested me different restaurant name. Now if I give Indian also, see, it has also given me Indian restaurant name. Now if I show you the chain memory, that means whether it has saved anything or not. So I'll just write chain.memory. See, it is none type. That means it hasn't saved my previous information. Whatever, let's say, question I have asked, it hasn't saved any kinds of information. Okay, you can see it's a none type. Completely it's a none type. Now if I want to add the memory functionality, what I can do, I can use actually 3 kinds of memory inside LangChain. I'll discuss all of them one by one. First of all, let's try to see conversation buffer memory. Okay, so just try to import LangChain.memory, import conversation buffer memory. Okay, now see, this memory will try to remember the previous conversation. Now first of all, create a memory object. You can see conversation buffer memory object. Now same thing, you have to initialize only another parameter you have to pass, memory is equal to memory. Okay, now again I'm giving Mexican food. Now I have given, let's say, Arabic food. Okay, now if I show you my chain.memory.buffer, you will see that it has remembered my previous context. So if human has given Mexican, then AI has replied. Again, human has given the, let's say, Arabic input, then again my agent has replied. That means it is trying to remember my previous conversation. Amazing, right? Now one issue actually will get with this conversation buffer memory, it can remember all the input it will be giving. Let's say whatever input it will be giving, all the input actually it will try to remember. So whenever it is trying to remember all the input, that means it is occupying your memory space. So I don't need to remember all the, let's say, context of the user. I can only remember, let's say, 5 to 10, let's say, context. It would be enough for me, because if you go to the ChatGPT also, it can only remember 5 to, let's say, 6, let's say, context, 5 to 6 conversation. Okay, apart from that, whatever things it will say previously, it will delete. Okay, so for this actually we can use another actually memory called conversation chain. Okay, now here I have already written conversation buffer memory goes growing endlessly. That means it can save all the information. And if I want to set only, let's say, 5 conversation, or let's say, or 10 to 20 conversation, that time I will be using conversation chain. Now here is the example of conversation chain. First of all, you have to define the conversation chain, and inside that you have to pass your LLM wrapper. Now let me show you the template. Now see, this is the template actually it will give you. Okay, now you can see current conversation, there is no conversation, that's why it's empty. Now let me do some conversation. So here I have given the first conversation, who won the first Cricket World Cup. Let's say this is my first conversation. So this is the output I am getting. You can see the first Cricket World Cup owned by the India in 1983. Okay, now here I will give another, let's say, prompt. How much is 5 plus 5? See, this is the irrelevant question I'm asking. Now this 5 plus 5 is equal to 10. Now again I'm asking who was the captain of the winning team. Now it will refer my this actually prompt. Okay, this context. Now see, the captain of the winning team in India was Kapil Dev. Do you have any other question? See, amazingly, it has remembered my previous let's say conversation. Okay, that's how also ChatGPT is working. I think the same example I have given you. You can also ask this question, like this add number code question. You will also see the same output. Okay, now if I show you the my buffer memory right now, so this was my input, then this was my like model output. Then again I asked this question, again this was the output, again I asked this question, this is the output. Okay, that's how actually you can save 5 to 10 conversation here. Okay, 5 to 10 conversation here. After that it will remove everything. Okay, now you can also set the window size, like how many conversation you want to save. You also have one parameter to set. For this you have to use something called conversation buffer memory window, sorry, conversation buffer window memory. Now just try to define the memory. Inside that just mention this parameter k is equal to 1. That means it will only remember one conversation. Okay, now just try to define this conversation chain. Inside that mention your LLM as well as the memory. Now if I again do the conversation, who won the first Cricket World Cup, now I'll again ask how much is 5 plus 5. Now it is giving me the output. Now again if I ask who was the captain of the winning team, now see, it is telling I don't have enough information context to answer this question. Okay, because I have only given k is equal to 1. That means it is only saving my one information. Okay, now if I give, let's say, k is equal to 3, now it will remember my previous 3 conversation. Let me show you. Now again if I ask this question, who was the captain of winning team, now see guys, it is giving me the output. Okay, now if I show you the conversation, now you can see it is remembering my previous context. Got it? So that's how whenever you are creating any kinds of application, guys, try to use this memory. Okay, memory inside your application. This will make your application very powerful. And now I think you are getting the logic behind ChatGPT, how ChatGPT is working. It's just an application, guys. Always try to remember ChatGPT is an application. Inside that, they're using large language model, which is nothing but GPT series. Okay, and whatever functionality they have created, this memory functionality, then chain functionality, prompt template functionality, they're using this kinds of framework, LangChain framework or Llama Index framework. There is another framework called Llama Index. This is the alternative framework of LangChain. We'll be also discussing this part as well. Fine. Okay, great. Now in the next video, we'll be learning about documents loader. Let's say whenever you want to build any kinds of RAG-based application, retrieval augmented generation, let's say you have some custom documents, and if you want to load these documents and you want to connect with your, let's say, a large language model, that time you have to load your documents. Okay, whatever documents you are having, whether it's a PDF documents, documents, or let's say TXT documents. Even you can also load the website also, just on any kinds of file format you can open, any kinds of website you can integrate here. Okay, so LangChain is very powerful, guys. You will be loving a lot, trust me, guys. So in the next video, we'll be learning how we can load the documents. Then after learning this, LangChain will be also implementing different projects, so that this concept would be clear, how we can load our custom documents, how we can create a RAG-based application, okay, how we can create a chatbot, different things we'll be learning. So if you go to the LangChain documentation, you will see we can also load different documents with the help of LangChain. So you can load, let's say, custom documents, let's say any kinds of file format, CSV, then a file directory, HTML, JSON, Markdown, okay, Microsoft Office, PDF, text, Twitter, okay, any kinds of documents you can load with the help of this LangChain. Even you can also connect different, let's say, platform. You can also connect Slack. You can also connect, let's say, Discord. And from there also you can extract the data. It's like very powerful, guys. You can go through the documentation. You will get each and every idea. Even they have also given the code snippet. Okay, how we can, let's say, connect with different, let's say, document format, and how we can load the documents. Fine. See, always try to remember, whatever, let's say, data we are loading inside LangChain, it would be considered as a document. Let me show you one example. So here, let's say I want to load one PDF documents. Let's say PDF I want to load. Let's say I'm having one PDF. Let me show you. So this is my research paper, guys. This is my research paper, guys. I published some years back. You can see I'm the author. So this is the author. Okay, I'm the author. Now you can see this paper is about actually development of multiple combined regression method for the rainfall measurement. Okay, and this paper is already published in the ResearchGate. Let me show you. If you go to my LinkedIn profile, this is my LinkedIn profile. You can connect me on LinkedIn, guys. You can follow me. So if you have any question, you can ask me there. I'll try to reply. Now see, if I show you this particular publication, so see, this is what I've already added. Now if I open this publication, see, this is the publication, and this is in the ResearchGate. Okay, even if you open the Google Scholar also, you will get it there. So this PDF actually I have downloaded, this paper PDF I have downloaded. Now what I will do, I'll just try to load the documents. Okay, whatever let's information I'm having in this, let's say, PDF, I want to extract these are the information. For this, I'll be using LangChain. So let me show you. First of all, I need to install one package called PyPDF. Now let me upload that PDF here. So my paper, I'll upload it here. Now see, it is getting uploaded. You can use any kinds of documents, guys, docs, TXT, CSV, JSON, anything. And again, visit the documentation, you will get all the code snippet. Let's say you want to use JSON. So this is the JSON, okay, JSON loader you have to use. Let's say you want to load CSV. You have to use CSV loader for this, okay. Now I'll be loading something called PDF. That's why I'll be using PDF loader. Okay, now see, this is updated. Now I'm importing this PDF loader from LangChain. You can see document loader, PDF loader. Now here you have to give the location of the file. Let's say this is my location. Okay, now you have to call loader.load. Now see, it will automatically extract all the information, and this data would be considered as a document. Let me show you. Always try to remember, inside LangChain, inside generative AI, all the data would be considered as a documents. Okay, that's why I think you remember in the vector database session, I was talking about documents. Okay, chunking documents, these are the thing. Okay, now I think you got it. Now see, it has extracted all the pages. Now see, this is considering as a document. This is the type of documents right now, and all the information present inside my paper. Got it? Now we can use this data to implement any kinds of RAG-based application. That means with the help of vector database, I can store these are the data with the help of embeddings, and I can connect my large language model, and I can ask some information there. Okay, don't need to worry. I'll be explaining this RAG concept and all. Okay, why RAG is important, why we have to create the RAG. Even we'll be also learning about fine tuning. Okay, how we can, let's say, take our custom data and we can perform the fine tuning. As of now, we have learned the fundamentals of LangChain, and I think I covered almost everything about the LangChain, whatever things you need to work with the LangChain. But I will show you some more advanced concept of the LangChain. This will also help you. Okay. So far, I think we have covered so many things inside LangChain. We have learned the entire fundamental concept of the LangChain. So one thing I wanted to tell you, see, LangChain also can work with this your pandas data frame. That means directly pandas data frame you can pass to the large language model, and you can ask some question there. Okay, it is also possible for this. You can use your large language model, any kinds of large language model, and with the help of LangChain framework, you can perform these kinds of operation. Let me show you. So first of all, I have to install some of the library. So here you can see I'm installing LangChain and LangChain experimental. Why LangChain experimental? Because this pandas data frame actually agents will be using. Now this is available inside LangChain experimental. Okay, that's why I have to import all of them. So let me import. And I'm going to use OpenAI large language model. That's why I'm using OpenAI here. Now I'm going to import some of the required libraries I need. Now you can see from LangChain experimental agents toolkits, I'm importing create pandas data frame agents. Okay, you can go to the documentation. You can see pandas data frame documentation inside LangChain, and they are also loading in that way. Okay, and they are giving a data set. Okay, any kinds of data set they are loading with the help of pandas, and they are performing lots of operation. Okay, so you can use different large language model, and you can perform chat operation. Okay, with this data frame. Let me show you. So let me import the library first of all. I'll import the pandas as well. I'll set my OpenAI API key. Then this is the data I want to load. Let's say this is the CSV data, Titanic CSV data. It is available in this GitHub. If I show you the live GitHub link. So this is the data, guys. It is already available. So let me first of all load this data with the help of pandas. So here is the data, guys. I think you are already familiar with this Titanic data. Now, first of all, we'll be performing this chat operation with the single data frame. So I'll initialize my large language model. Now create a agent. To create agents, just call this create pandas data frame agents, this class. Inside that, give the LLM data frame. Verbose is equal to true means it will show you the entire, let's say, execution details. And here you have to give another parameter called allow dangerous code is equal to true. Now I'll create the agents. Now here I can ask the question right now. I'll ask how many rows are there in the, let's say, data frame. Now see, it will count and it will automatically give me the answer. See, around 891 okay rows are available. I will give another question. How many people have more than 23 ages? See, amazingly your model will try to go through that data frame and it will give you the answer. See, 468. Now I can also work with multi data frame. So for this, what I can do, I can copy this data in another variable called df1. See, I'm copying this df only. Now I'm creating another df1 here. This is the data. Now what I will do, I'll just fill the none value, okay, which is present inside age, because age is having some none value. I'm just filling. Now again, I'm creating the agents. You can see. Now here you can see I'm giving multi data frame df and df1. Okay. Now let me create the agents. Now I'll ask one question. How many rows in the ages columns are different? Okay. Now let me show you. Because I already filled the information. Now around 177 rows have the null value. Now you can see rows have different values in the age column. I think you got it. Now I'll create another data frame called df2, and now I will just multiply 2 with the age. Whatever age I'm having, I'm just multiplying 2. Now this is the results. Now I'll create another agents and it will have 3 different data frame. Okay. Now let me create the agents. Now I'll ask one question. Are the 3 of the columns same in the all the data frames or not? Definitely it should be same for all the data frame, because I have just copy pasted the same data frame again and again 3 times. So here all the column name should be same. So if I show you the output, see. So see guys, I'm getting the output agent stopped due to the iteration limit or time limit, because I'm executing multiple time now. That's why I just use the limit. Okay, that means my limit has been done. So what you can do, you can restart the runtime again. You can execute the entire code. You will see that all the column should be same, okay, in 3 different data frame. Okay, we'll get this kinds of output. Now you can ask any kinds of question, okay, about this data frame. So this is called actually multi data frame agents inside LangChain, and this like again very powerful concept if you want to work with the data frame and all. Going forward, we'll be also implementing some projects with that. Okay, this concept will help you a lot. So as of now, I think I showed you lots of example, lots of demo of the LangChain, like what are the things we can perform. Even I also told you we can also, let's say, access different open source large language model from the Hugging Face itself. Okay, so this would be the dedicated video about this LangChain integration with the Hugging Face. So there you will see that how we can access different model with two kinds of method. Like one method I will show you how we can access through the API request. Other method I will tell you how we can download the model, okay, in our Google Colab, and how we can use this particular model. Okay, this is the idea. So first of all, let me install some required package. So you can see I'm installing LangChain community, Hugging Face app, Transformer. Why Transformer? Because I want to use a Hugging Face platform. I want to download the Hugging Face model. That's why Transformer is required. I think I already taught you about the Hugging Face, like how to use Hugging Face and what is Transformer library. Everything I already discussed. And these are some actually dependency package you need to also install with the Hugging Face. That means your Transformer. Now let me install all the library one by one. So guys, as you can see, my installation is completed. Now let's import some of the library. You can see I'm importing prompt template, Hugging Face app, LLM chain from the LangChain itself. Now, first thing what you have to do, you have to setting up the environment. For this, you have to set the Hugging Face API token. And how to get the Hugging Face API token, I think I already explained. Go to the settings and left hand side, you will see access token option. So you can create a new token here. I already showed you how to create a token. Okay, so I'm not going to show you again. So now let me set my token. Now we'll be learning the first approach, like access the hosted model on Hugging Face through API request. Okay. Now see, here we'll be accessing one text to text generation model. So first of all, let's create a prompt template. So here's the prompt template I have prepared. What is the good name for a company that makes product? So product should be my input here. Now here I'm creating the LLM chain. I'm giving my large language model, and you can see I'm using Hugging Face app and I'm giving this model ID. That means I will be using this model. So this is the Flan T5 model. This is from Google actually. So we'll be using this model here. So let me load this model, and here is the model arguments. That means temperature and max length parameter, and here I'm giving the prompt. Okay, the prompt template I've created. Now let me create the chain object. Now here you can give the output. Let's say I will give colorful socks. Let's see whether it is able to give the response or not. See, it has given me sock mania. Okay, this should be the name. Now let me show you another prompt. You can see I have written another prompt. Can you tell me about famous footballer? So it will take the famous footballer name and it will tell you about him. So let me show you. So again, I'll create the chain and see the same code actually I'm using. Now if I give Messi, now you can see guys, it is giving me the response. Messi is a footballer who plays for Argentina. Great. Now you can give another prompt. Let's say, can you tell me food items for the cuisines restaurant? So cuisine should be the input. Let's create. And I'm using the same code snippet. Now let me initialize the chain and let me give the input. Let's say Indian. Now see, it is giving me vegetable. Okay. Can you tell me the food items? Yeah, vegetable is fine. Now if I again execute, let's see. Okay, vegetable it is giving, because I told you, this model is not good. Now guys, let's see how we can use any other model. See, again, I have prepared one prompt template, and again, I'm using the same thing. Can you please tell me about famous footballer? Now, see, instead of this T5 model, I'm using Falcon 7B. So this is one of the large language model. It is already available in the Hugging Face. Okay, you can see. So this is the organization, they published this Falcon, and Falcon is having different variant, Falcon 7B, 13B. Okay, that's how it is having different variant. And this is one of the like great large language model you can use. Now let me show you one demo. Now let's load it and see, I'm using the same code snippet and I'm sending the request. See, this model actually I'm not downloading in my machine. So it is using the API to access the model, and it is giving me the response, and that response actually I can see. Okay. Now see, this is the response I got, and it's like very detailed response I got, okay, than your previous response. Now let's see the approach to like how we can download this model locally and how we can create a pipeline. That means that Hugging Face pipeline, I think, remember, right? For this, let's import Hugging Face pipeline from LangChain. Then I'm also importing some additional library like auto tokenizer, auto model for casual LM, then pipeline. Okay, these are the thing I'm importing because I think you remember how to create the pipeline. So let me import them. Now see, I'm using this Flan T5 model again. So let's initialize the model. And first of all, I have to create the tokenizer. If I want to download the model, I have to create a tokenizer. I think you know that, right? Tokenizer will pre-process your input. That means it will process input. It will create the embeddings, and then it will pass to the model. Now here, I'm going to initialize my model. You can see I'm giving the model ID. Then device map is equal to auto. That means it will load the model inside my GPU. And make sure whenever you are like downloading the model locally, you are using GPU based machine. Okay, good configuration machine. Otherwise, execution time would be very like slow. Okay, but if you're accessing through API, you don't need a GPU based machine. Now let's create a pipeline. You can see it's a text to text generation model. So here I've given text to text generation model, tokenizer, and max length. Now let me create the pipeline. Now I'm going to initialize my LLM wrapper. So I think you remember we called this Hugging Face pipeline from LangChain. Now, so here you can see I have initialized my LLM wrapper and pipeline. The pipeline object I'm getting, I'm passing inside this Hugging Face pipeline. Now this is going to be my wrapper. Now again, I'm going to create the prompt template, and this is the example I have taken, the same company. Okay, company example. Now let me pass to the LLM chain and as well as my prompt. See, I'm passing my large language model as well as my prompt. And now see, the model actually I'm passing, this model actually I've downloaded. Okay, LLM, local LLM, not the API one. Okay, so both way you can use this Hugging Face. Now let me show you the results. See, Socks Mania. Now let me prepare another prompt. Can you tell me about famous footballer? Now let me initialize the chain. Now let me ask about Messi. See, Messi is a footballer who plays for the Argentina. Okay, so that's why, guys, we can access Hugging Face model, open source large language model with the help of LangChain. And going forward, we'll be using this concept, guys. And with this concept, we'll be implementing so many applications. So this project will be implementing with the help of whatever things we have learned so far. Let's say LangChain, large language model, vector database. Okay. Even we'll be also implementing one front-end application of this project. That means user will get one user interface, and their user will upload the data and they will get the results. Okay, so these kinds of things actually will be also implementing. That means I'm going to show you the complete project structure here. That means we'll be doing modular coding here. But before that, I'll show you the notebook experiment, like how we can implement this project through the Jupyter notebook. Then I'll try to convert this Jupyter notebook to the end-to-end manner. Okay. So I think you saw the name interview question creator. I think you are already getting what is the project about. Interview question creator means, let's say you are having one PDF documents, or let's say any kinds of documents, whether it's a docs documents, PDF documents, TXT documents, or whether it's a books. Okay. So what you have to do, you just need to upload that, let's say PDF to this application, and this application will automatically generate the questions. Okay. Question as well as the answer. Okay. Of the topic actually will be giving. Let's say you have uploaded one Python PDF here. So this application will generate some Python questions, interview questions, as well as the answer. Okay. And that question and answer you can use, let's say for your candidate, or let's say you are a teacher and you want to generate interview questions, or let's say exam questions. What you can do, you can use this application to generate this kinds of question and answer. So it would be very easy for you to generate this kinds of question. Otherwise you have to manually find the questions, manually, let's say, prepare the answer. So it will take time. But if you are creating this kinds of application, it will help you a lot, okay, to automate your process. Again, it seems like a simple project, but whenever you will be implementing, you will get the complexity. And this is like very interesting project because this is the first project I should be implementing after learning LangChain. Going forward, we'll be also implementing some advanced projects, like we'll be implementing medical chatbot, source code analysis. Okay, so these are the things we'll be also implementing. So instead of talking too much, guys, let's start the implementation. But before that, I will show you the, let's say, the requirements actually I need to implement this project, and I will also show you the project architecture. So guys, to implement this project, I need some requirements. Okay, I need some requirements. So here we'll be using LangChain to implement the entire, let's say, project. And why LangChain, I think you know, because LangChain having all the functionality, right? Let's say you want to integrate vector database, you want to integrate large language model. Okay, everything is available here. So that's why we'll be using the complete LangChain here. And large language model wise, we'll be using OpenAI model. OpenAI will be using GPT 3.5. Okay, this model actually will be using. Going forward, we'll be also learning how we can use open source large language model. With the help of that, I will also show you how we can create the application. Now, third, I need vector database, vector DB. So here we'll be using FAISS. Okay. So FAISS is another actually vector database. I think I haven't covered in my vector database series. So that's why I thought let's also show you this FAISS in this video, so that you will be also learning about FAISS. So FAISS has implemented by Facebook AI, and this is one of the vector database. This is the local vector database actually, local vector database. So you have to set up everything in local machine. Going forward, we'll be also using Pinecone Web 8. Okay, no need to worry. Then to implement the entire, let's say, front-end part of our application, that means we'll be creating the user interface with the help of Fast API. Fast API. I think you know what is Fast API. Fast API is a Python framework. With the help of Fast API, we can create a user interface web application. Apart from Fast API, we're having, let's say, Streamlit, Flask, Django, okay, Falcon. So these are the things you can also use. We'll be exploring one by one all of them. I think we saw the Flask previously. I think remember Flask. I think I showed you. We created some of the application with the help of OpenAI. We'll be also using Streamlit. Streamlit is very easy. If you are using Streamlit, you don't need to write any kinds of HTML and CSS code. So guys, yes, as of now, these are the requirements are needed. If I need it later on, I'll tell you. Okay, now let me show you the project diagram. Okay, the project, let's say structure. That means the high level architecture. So here, first of all, user will, let me just draw it here. First of all, user will upload one PDF documents. Okay, let's say this is the PDF documents. So what I have to do, I have to extract the data. Extract docs. So why I have written docs? Because I think you already know, if I am using LangChain and if I'm, let's say, extracting any kinds of data from any kinds of PDF or any kinds of, let's say, file format, it would be considered as a documents. I think I already covered multiple times, like LangChain data loader. Even I also showed you inside vector database session. So guys, vector database session is very much required here, because inside vector database session, I have explained each and everything you need to know to implement any kinds of project. Okay, how to connect the LLM, what is documents, what is chunk overlap, everything I have discussed there. So please go ahead and try to watch that, let's say, session first of all, then you'll be able to understand, okay, what is happening here, because here I'm not going to explain in detail everything. We are implementing the project only, and we're using our previous concept. Okay, this is the idea. So make sure you complete that vector database series first of all. Fine. So we'll be extracting the documents from the PDF. Then we have to create a chunks. And what is chunks? I think I already told you why chunking is required, because LLM is having one kinds of input limit. Okay, but, so that's why actually we have to create a chunks. Okay, chunks. Then what we'll be doing, we'll be using one embedding model. What is embedding model? I think you already know. I already explained inside my vector database session. Embedding model will help you to generate the vector embedding. Okay, because I have to convert these chunks to the vector embedding. So this will give me something called vector embedding. Okay, vector embedding. Okay, embedding. And with this vector embedding, we'll be creating one semantic search. I already explained what is semantic search. Semantic search, because I think you know the power of vector DB. It will give you one semantic search kinds of functionality. Now what I have to do, I have to store this vector to a vector database. Vector database, because if I want to perform the semantic search operation, I have to use the vector database. Okay, I think you already know. Now guys, you can see my knowledge base has been created. So this is called actually knowledge base right now. Okay, knowledge base, because it is having the entire information about my data. Now I'll be connecting my large language model here. So let's say this is my large language model. LLM, that means that GPT 3.5. Okay, so this large language model I'll be connecting here with my vector database. Okay, and here I'll set a prompt. I'll just set a prompt here. So inside this prompt, actually I'll be writing what kinds of, let's say, task it has to perform. So here I'll be writing, you are a expert interview question creator. So what you have to do, whatever, let's say, data user will give you, you have to create a interview questions. Okay, or let's say 10 questions, 20 questions, you have to create it. Okay, this is the idea. So this kinds of prompt actually I'll pass to the large language model. So I think you already know prompt is everything. If I'm using any kinds of LLM, right? So with the help of prompt, we can achieve our task. This is the main idea. So this LLM will go to the vector database that time, and because vector database is having all the information about the PDF, and it will create, okay, it will create what? It will create you interview questions. So it will return interview questions. Interview questions. Okay, fine. Now what I told you, I'm not going to take only the interview question. I will also going to take the interview question answer as well from the large language model. So again, what I will do, whatever questions actually I'm getting, again I'll pass. Okay, again I'll pass to my large language model. Again I'll pass to my large language model, and I will tell my large language model also provide the answer, the questions you have generated. So it will give me the answer that time. So it will give me questions answer, okay, as well. So this is going to be my complete project architecture. Okay, so based on this architecture, we'll be developing the entire projects. Fine. So first of all, let's do everything in my Jupyter notebook. Then once Jupyter notebook is working fine, then I'll show you the let's say modular coding implementation as well. So for this guys, what I will do, I will open up my local folder, and here I already created one folder here, empty folder, and inside that I'm going to open up my terminal. Okay, so in case if you're using Anaconda, Git Bash, whatever terminal you are using, you can open it up. Now here I'm also going to open up my Visual Code Studio. So let me open up my Visual Code Studio. Now here the first thing what I have to do, I have to create one virtual environment. I think I already told you. You just need to create a virtual environment every time whenever you are creating different projects. So to create the virtual environment, you have to execute some of the commands. So let me share the command with you as well. So here I'm going to create a file called readme.md. So this is the markdown file. Inside that I can mention all the command, and this file will help you to render actually these kinds of messes in the GitHub. So let's say whenever you will be uploading this code to the GitHub, that time you'll see that in the GitHub description, that means your project description, all the details has been written. Okay, let me show you one example. So guys, this is my GitHub profile. You can follow me here also, because here I have created lots of repository that might help you a lot. So let me show you my repository guys, one of the project actually I implemented previously. So let's say this project, okay, MLOps production ready machine learning project. So this is the project actually I created. Now if you open this project and if you go to the readme section, you will see that the complete details about my project. Okay, see the complete details about my projects, like how we can set up, what is the workflow, what are the command you have to execute. Okay, everything I have set here. So how it is rendering, it is rendering because of this readme file. You can see a readme.md file. Okay, so that's why we are getting this readme file here, because whatever things you will be writing here, it will render in the GitHub later on. Fine, this is the idea. So here some of the common command you have to execute every time. Let me show you all the command. So see guys, these are the command you have to execute. First of all, you have to create the environment. After that, you have to activate it. After that, you have to install the requirements. To install the requirements, you have to execute this command. Okay, pip install -r requirement.txt. So let's create a file here. I'll name it as requirement.txt. I'll copy and let me create the file as well. Okay, now first of all, create the environment. So copy this command and open up your terminal and execute it here. Okay, execute it here. For me, I already created the environment. What I'll do, I'll just try to activate it. But for you, you just need to create the environment. So for me, let me activate. So this is the environment I created already. Interview, you can see. Fine. Now inside interview, I have to install some of the required package. The package actually I need, I think I showed you the LangChain, OpenAI, then vector database, fast API. Okay, everything I have to install here. So I already listed down all the required package you need. So these are the packages guys you need. Okay, you need to install. So you can see LangChain, LangChain community, LangChain code. So these are the actually dependency packages if you want to use LangChain. So you have to install it. And again, we are doing local setup guys. That's why some additional package you can see. Otherwise, what will happen actually, you might get issue, installation issue. That's why I have added everything. Now OpenAI, PyPDF, why PyPDF? Because user will upload PDF documents here. As of now, we are considering PDF documents. Fine. And TikToken is the dependency of OpenAI. Then you can see AI files, fast API, UVCon. So these are the dependency of fast API. I'll tell you whenever we'll be using these at the package, that time I'll explain. Okay, as of now, just consider these are the packages actually I need to implement the entire projects. Okay, now you can see we'll be using Fias, and to install the Fias, you have to execute this command Fias CPU, then python.env, because I have to manage my secret credential. Okay, now let me save everything and you have to install it. To install it, this is the command guys I already shared. So copy the command and let's execute it here. For me, I already installed all the package. That's why it's telling requirement is already satisfied. But for you, it will take some time. Okay, now let me clear. All right, now first thing, I'm going to create a folder here called research. Inside the research, I'm going to create a notebook. I'm going to as experiment. I'm going to name it as experiment.ipynb because this is the Jupyter notebook file I want to create. Okay, that's why it's ipynb file. Now let me select the kernel. So the environment I created, this interview. Okay, I'll select it up. Now here, first of all, let's import some library. I need the operating system. Then I also need .env. So from .env import load env. Now let me execute. See, it's working fine. So I think remember I have to create a .env file here. Inside that I have to mention my OpenAI API key. So let me do it. So guys, as you can see, I have created this .env file. Inside that I mentioned my OpenAI API key. Okay, so for you have to do the same thing. Now let's load this OpenAI API key. So to load it, I'll call this load env. After that, simply I'll call the key OpenAI API key. And I'm going to use os.getEnv. Inside that, I'm going to pass my key. Okay, so this will give you OpenAI API key. Let me show you. See, okay, it is printing the OpenAI API keys. Now let me comment as of now. I don't need to print it. Fine. And now what I have to do, I have to set this OpenAI API key as an environment variable. So for this, you have to execute this line of code. So it will set this OpenAI API key as an environment variable so that OpenAI package will load, okay, from the environment itself. I think I already explained previously this part, okay, how to do it and all. Now the first thing what I have to do, guys, I have to load the data, but I don't have any data here. So let me show you some of the PDF actually I'm having. So guys, as you can see in the data folder, I'm having actually two PDF. One is like SGD PDF, one is like stats PDF. Let me show you. Let me open the PDF and let me show you. So if I go to the data folder, so this is the PDF, guys, I downloaded from the internet. So the PDF name is Sustainable Development Goals. Okay, so about this topic, actually they have written this PDF. You can see what is sustainable, let's say, development and all. They have written this particular, let's say, PDF. So this is one PDF actually will be using to generate the interview questions. Let's say you want to generate interview question based on this topic. Okay, so you can use this PDF. Not only this PDF, guys, you can use any kinds of PDF, whether it's a Python book, any kinds of physics, chemistry, English, okay, anything you can use here. It's up to you. So this is the PDF, guys, actually I'm having. Now the next PDF, let me show you. So this is the statistics PDF. So this is the topic of importance and the use of correlation in statistics. And again, you can see correlation topic has been written. So we'll be also generating some interview questions based on the statistics. Okay, that means the correlation. So these two PDF actually I just downloaded from the internet. Okay, now let's load the data here. So I'm going to open up my notebook. So to load the data, you have to, I think remember, you have to import one, let's say, function from the LangChain. So let's import it from LangChain dot documents loader. Okay, documents loader, import import PyPDF PyPDF loader. I think, yeah, this one, PyPDF loader, because it's a PDF document, right? Now let me import it. Now one thing I want to show you. So let's say if I show you my project working directory right now, so let's say pwd, this is the command to check my project working directory. Now you can see that I'm inside my resource folder. Okay, you can see I'm inside my resource folder. So because this experiment.ipynb is available inside my resource folder, but where is my data located? Data located outside of the resource folder, yes or no? Because outside of the resource folder data is available. Okay, now if I want to go back, to my root project directory, that means LangChain project, what I have to do, I have to execute one command. This command is cd dot dot. Okay, cd dot dot is the command. So this will actually go back one folder back. Let me show you. So now see, if I execute the command, now if I again check the project working directory, now you can see that I'm inside my root directory, that means this directory. Okay, LangChain project. Now I can easily access my data right now. Okay, this is the idea. So make sure you always check the path, project working directory. Okay, if you're working with, let's say, Jupyter notebook in a specific folder. Okay, this is the requirement. Now let me define the file path. File underscore path is equal to, so my file is present inside my data folder. Okay, data. And let's say as of now I want to load this sgd.pdf. So it should be SDG. Okay, sustainable development goal. This PDF I want to load. PDF. Okay, and to load it I'll be using PyPDF loader. Inside that I'm going to pass my file path. Okay, and it will give you loader object. Now I'm going to load the data. So I'll just write data is equal to loader dot load. That's it. Now see, if I execute, it should load the data. Now if I show you the data, see, so the complete documents, so guys, you can see it has extracted all the data from the PDF itself, and it is having around 24 pages. You can see it has started from 0 till 23. That means 24 pages actually it is having this PDF. If I open this PDF, you'll see that 24 pages it is having, and all the page content it has extracted. And some of the places you can see page content is equal to empty, because in this page actually there is no content, that's why it's empty. And whatever actually documents I'm having, it has extracted, okay, one by one everything. Now if I want to show you the length, you can see 24 pages are available, okay, in the PDF. Now what I have to do, see, it's a separate page content now I'm having. Now I want to, let's say, store all the data in just one variable. So for this, what I will do, I'll just take a variable here. So let's say variable name is question underscore gen. You can give any variable name, it's up to you. It should be initially empty string. Now I'll just write a for loop. So for page in, let's say, data, let's say the complete data I'm having. So it will give me all the page one by one, and I just need to extract the content. So question gen plus and equal. I'll be just adding, okay, in this variable, okay, this is the idea. I'll just write page dot page underscore content. Okay, so it will give me all the content one by one, and it will save inside this question gen variable. Now let me show you. Now if I print my question gen, now see, all the data I have extracted, okay. See, now it is in one place only. This is the idea. Now see, this part actually have completed. That means whatever PDF I uploaded, I extracted the entire documents, okay. Now what I have to do, I have to do the chunking operation. That means I have to create a chunks for my large language model, because if I want to, let's say, generate the embeddings, before that I have to do the chunking operation. I already explained this part, I think you remember. So to perform the chunking, we'll be using one package. So it is available inside LangChain. So for langchain.textSplitter, so we'll be using one text splitter here called token text splitter, okay. So previously I think we used something called character text splitter, then recursive text splitter. I think you remember we use character, okay, character text splitter, okay, splitter. So with the help of that, we can perform the chunking operation, I think you remember. Then we also have something called recursive okay, text splitter. So again, this is another method to perform the chunking operation. And now we'll be using something called token text splitter. Token text splitter. Now what is the difference between token text splitter and character and recursive? See, let's say this is my entire documents. So I think remember we used to perform something called chunk size. Okay, chunk size. Let's say 500, and there is another parameter called chunk underscore overlap. Let's say it's 100. Okay, now how it will create the chunks, I think remember, first of all it will start from the first and it will count 500 words. Let's say 500 words ends here. So this is our first chunks, okay. And to start the second chunk, first of all it will apply the chunk overlap. Let's say 100 word back actually it will go. So it will count 100 word. Let's say this is the 100 word start from here. So it will start the second chunks from here, and again it will count till 500 word. Let's say 500 word ends here, okay. So this is my second chunk, okay. So that's actually it will perform the chunking operation. Now you can see there is a chunk overlap you got. So this is called actually overlap, okay. This is called overlap, and with this overlap actually my model will understand after this first chunks, this chunks is coming, because you can see it is getting overlap now. This is the actually manual approach actually we can consider. This is the manual approach we can consider to get the context of my first chunks and second chunks, okay, and so on, like whatever chunks actually we are defining here. But this is actually what we do in the character text splitter or recursive text splitter. But what about token text splitter? See, token text splitter, what it will do, instead of using actually this manual approach, it will use one large language model. In case actually we'll be using something called GPT 3.5, okay. So this GPT 3.5 will decide, okay, how to create the chunk, how to perform the overlapping, and it will automatically remember, let's say after this first chunks, this second chunks is coming. After second chunks, this third chunks is coming. After third chunks, this fourth chunks is coming. Okay, your large language model will try to remember this part. Okay, and this is like more powerful method than your previous one, whatever, let's say, method you used previously, because now LLM is like remembering everything, the context. Okay, that's the idea here. So let's try to export this this token text splitter. So for this, I'm going to open up my notebook. So I already imported. Now let me execute. Now see, this is the syntax to use the token text splitter. So I think you remember previously we didn't use any kinds of model name whenever we used to perform the, let's say, chunking operation. Now you can see I'm using the model name. I'm using GPT 3.5 Turbo. That means my model will try to decide, okay, how to remember the context. Now you can see this is the chunk size. Chunk size I'm expecting 10,000. Okay, 10,000 actually what would be considered as one chunks, and chunks overlap should be 200. Okay, as of now, let's say this is the things I'm just showing you, just to show you, okay, how it will work. It's just an experiment. Okay, I'm just showing you how it will try to create the chunk. Now let's define the splitter. Okay, this is my splitter. Now inside that, I'm going to pass my entire documents. So you can see the entire questions and documents actually I'm passing to my splitter. Okay, splitter objects. You can see split text. Now it will give me chunk questions, and that means the chunking. Okay, it will give you the chunking result. Let me show you. So here is the chunk I got. See, this is the chunk I got. Now how many chunk it has written? For this you can use length function. You can check. See, it has only given me one chunk. Because why? The PDF, you can see this PDF is DG. So if you count all the words, it won't be actually 10,000 words. Okay, it won't be 10,000 words. It is less than 10,000 words. That's why here I've given chunk size is equal to 10,000. It is only considering one chunk the entire documents, because I told you if you count all the, let's say, word, okay, in this let's say PDF, it won't be 10,000. Okay, because it's a like huge size I have given here, just to show you, okay, how chunking will happen. Now let's perform our actual chunking. For this, what I have to do, I have to first of all convert this actually data to the document format, because you can see now it's a list format. Okay, if I show you the type, okay, if I show you the type of this one chunk question, it's a list. Inside that, if I just extract the first element, it would be a string. See, it's a string, but I have to convert to the document representation. So for this, what I will do, I'll import one class from LangChain called docstore documents import documents. Okay, with the help of documents, we can easily convert any kinds of string to document representation. Okay, now let me show you. See, now whatever, let's say, data you got, that means your this one chunk question gen. So I'm applying on for loop. That means it will give me all the, let's say, data one by one, and I'm converting to the documents, you can see. Okay, and I'm storing in this particular variable. Now if I execute, now see, I got the documents and it is format of documents right now. Okay, now if I show you the type of document question gen, it should be a LangChain code document base document documents. Okay, it's a now document format, because if I want to apply the splitter, so first of all you have to convert everything to a document. This is the recommended way. Okay, if you're also giving the, let's say, string directly, it's completely fine, but this is the recommended way. First of all, convert everything to the document format, then try to use the splitter, that means the chunking operation. Now I'll do the chunking again. See, again token text splitter. Again, I'm using GPT 3.5 Turbo model. Now I've given the chunk size is equal to 1000. That means 1000 word I want to consider as one chunks, and chunks overlap is equal to 100. Okay, now let me execute. Now let me give my documents. Now you can see document question gen. Okay, I'm passing it to my splitter. Okay, splitter object right now. Now it will give me the chunk. Now let me show you. Now see, I'll get multiple chunk here. So I got here 4 chunks. Okay, 4 chunks actually I got from the entire PDF. Now if I show you the length, see, 4 chunks I got. Fine, I think it is clear now. So guys, as you can see, we successfully created the chunks. Now the next thing what I have to do, first of all, I will generate the questions. Like whatever, let's say, chunk I have created, I will pass to my large language model and I will generate the questions. Okay, interview questions based on the prompt actually I'll be providing. I think you remember, we'll be passing one prompt to the large language model. Okay, so with the help of this prompt, actually, I'll tell my large language model, I need a interview questions. Okay, let's say the documents I have given, based on that, it should provide me some interview questions. That's what actually I need to perform. So for this, I don't need to convert these documents to the embedding representation, because as of now we are only passing the, let's say, documents to my large language model. Large language model will give me the questions, but later on, whenever, let's say, I'll be doing the answer generation, okay, the complete answer generation, that time actually I need to pass the entire documents, okay, and it will create the vector embeddings and it will store to the vector database, okay, and vector database, I'll connect my large language model, and large language model will refer this entire information to give me the answer as well. Okay, this is the idea. So let's define my large language model right now. So here I already told you I'm going to use something called OpenAI large language model, that means GPT 3.5, okay, this model. And to use it, I can use this class actually chat OpenAI. You can also directly import OpenAI, it is completely fine, but we can also import like that, okay, both way you can import. And if I am importing like that, so here I can also give my model name, that means which specific model I want to use, whether I want to use, let's say, GPT-4 model, 3.5 model, you can use. So let me show you. So this is the code snippet. So chat OpenAI, inside that you can give the model name. Let's say I want to use GPT 3.5 turbo model, and this is the temperature parameter. You can also give max length parameter and so on. So temperature parameter is a creativity parameter, I already explained, okay, what is the temperature parameter. Now let me define my LLM. Now here I already created one prompt, guys, prompt template. Let me show you. So this is the prompt I have created, guys. You can see you are an expert at creating questions based on the coding material and documentation. See, whenever I designed this prompt, actually I was like generating coding related questions, and now I'm using any other documents. You can see that means the this one, sustainable development goal and statistics one. So if you're using statistics one, that time you need to give statistics material. If you're doing sustainable development goal, you have to give sustainable development goal here. That means whatever subject you are referring, you have to give the prompt with respect to that, because it's a changeable prompt, is changeable, okay, you have to change every time based on your requirement. Now your goal is to prepare a coder for a programmer for their exams and their coding test. You do this by asking the questions about the text below. That means whatever, let's say, data user will provide, that means these chunks, okay, based on that it will create interview questions that will prepare for the coder, a programmer for their exam test. Okay, make sure not lose any important information. Okay, this is the prompt actually I have created, and I already taught you like how we can design a efficient prompt. What is the art of, let's say, design a prompt? I already took on session on the prompt engineering. That session you can refer. Okay, so that's how always you have to prepare a good prompt. Whenever you are preparing good prompt, that means you will get a good response from the large language model. This is the idea. Now let me define the prompt. Now to use this prompt, I think I already taught you one concept called prompt template. You have to use something called prompt template from the LangChain. So let me show you. So this is the code snippet, prompt template. Okay, so here I'm passing the prompt template I've created, and this is the input variable is text. That means user will give this data. Okay, this is the input variable. I think it is clear. Now let me execute the prompt. Okay, now this is my template right now. We can do another actually very important, let's say, technique here. See, if you're not doing it, it's completely fine, it will work. But I was going through some of the research article, and I got to know people are using something called second layer verification. That means they are doing refined prompt template. So what is refined prompt template? Let me show you. I created one prompt template. See, this is the prompt template I again created. That means whatever questions actually your model will generate from the first prompt, you have to give those questions to the second prompt. That means it will refine that particular question. Let's say if there are some issue with the question, if let's say this question is irrelevant based on the topic you are asking, again this refine prompt template will try to refine, and again it will give you some new questions, okay, on top of it. So here you can see I've written the same prompt again, but one more additional information I have added. We have received some practical questions to certain context. That means it will give me some question. Okay, this question actually I have to give to my second prompt, and second prompt will try to check. We have the option to refine the existing questions or add new one only if necessary with some more context below. That means if some issue is there, if let's say it is irrelevant, that time what it will do, it will try to rectify that question. Okay, this is the idea. Give the new context, refine original questions in English. If context is not helpful, please provide the original questions. This is the idea. So this will actually refine prompt template. You are refining the questions here. That is the idea only. And this is like very powerful method, guys. If you are using, you will see that your result would be pretty good. If you're not using it, it's completely fine. No need to worry. But I'm showing you because see, we are creating an advanced application, and in advanced application, we have to take care. These are the part. Okay, this is super important. Let's also define this refine prompt template. Again, I'm going to use prompt template. Inside that, I'm going to pass the input variable. Now input variable is two. One is this existing answer. The existing answer I will get, and the text. That means again you have to give the entire text. That means the chunks. Okay. So these two input now you have to give. You can see text and existing answer, and it will give me the refined prompt template. Fine. Now I'll generate the questions. For this, I need to integrate my large language model as well as the prompt template. For this, I'm going to use one function from LangChain called load summarize chain. Okay, previously I think I showed you we can use chain. Okay, only chain we can use. Now there is another chain actually called load summarize chain, because inside LangChain you are getting different chains. Okay, we are using this particular chain, actually load summarize chain. Now we'll be creating my entire chain. See, this is the entire chain. First of all, you have to give the large language model. Okay, the LLM we have defined GPT 3.5. Then chain type is equal to refine, because we have prepared one refined prompt template. Okay, that's why it's a refine. Verbose true, that means it will show you the execution, all the, let's say, logs. Then here I'm giving the question prompt. First of all, the prompt I have defined at the very first. Okay, this is the question prompt. Okay, because it's a chain, it will execute after one after another. Okay, first of all it will execute, and whatever question actually I'll be getting, I'll pass to the refined prompt template. Okay, you can see refined prompt template. Okay, now this is going to be my chain right now. And now simply I'm going to pass the document question. That means this one I have to pass, this one. That means the entire document. Okay, this document I have to pass right now to my large language model, and it will give me the questions. Okay, it will give me the questions, and these questions I'm printing. Let me show you. See, it is generating and it is giving all the information because you have defined verbose is equal to true. Now see, these are the questions I got. I got 10 questions. Now if you want to get 100 questions, you can define here. You can define inside the prompt. I need 100 questions. Okay, you have to generate 100 questions. It will generate 100 questions. By default, it's generating 10 questions. Now if I want to show you, I will open in a text editor. See all the 10 questions I got here. But apart from that, I'm getting some more additional information. I don't need them. I only need the questions. You can see 1 to 10 questions it is giving me. What is the main goal of the sustainable development goals method? What are the some key achievements in the, see, that means if you read these questions, it's pretty good. Nah, as a human, if I tell you just prepare the question for me, I think you will be thinking in that way. Okay, this is the idea. That means my answer is pretty good, guys. And why I got the pretty good answer? Because I used the refined prompt template. Okay, so this is another powerful concept you can use. Okay, so now we'll be creating the next part. That means we'll be using the embedding model. We'll be generating the vector embedding and we'll be storing to the vector database. Okay, because I also need to generate the answer right now. Fine. So this is what I have to perform. So let's do it. So for this, first of all, I have to define one embedding model. So here I'll be using OpenAI embedding model. So for this, you can import from the LangChain embeddings OpenAI. I need OpenAI embedding model. Okay, so let me initialize. So here I'm going to use OpenAI embedding model. So if you go to the OpenAI website and if you go to the model section, you'll see that OpenAI also provides lots of embedding model. Okay, so you can use any of them. Now I also need to initialize my vector database. So here I'm going to use FAISS vector database. I already told you. So it is available inside LangChain vector store FAISS. You can also use ChromaDB, Pinecone, Weaviate. It's up to you. But I'm going to use the FAISS because I need to show you the FAISS as well. Okay, and FAISS is very like fast. I mean than your ChromaDB. Okay, you'll see that it's like very fast, quite fast. Now let's initialize my vector store. See, that's how you have to initialize the vector store FAISS from documents, and you have to give the documents here, like which document you want to create the embedding. I think remember we created the chunks. These chunks, I think remember. Document answer gen. These chunks I have to pass, and I have to create the embedding. Okay, and I have to give the embedding model. This is the embedding model I'm passing. So this will give you the vector store, and it will save locally, guys. Okay, it will save locally. You won't be able to see that. Okay, it will save in memory actually. And if you want to see that, you can store in the cloud based. I mean, you can use the cloud vector DB that time. In the cloud, you can save. I think I showed you the Pinecone. There you can see the visualization of your vector. Okay, it's possible. Now let me again initialize my large language model. You can see again I'm using GPT 3.5 Turbo large language model to generate my answer, because you can see I told you na, the question I'm getting, I'll again pass to my large language model. Large language model will give me the answer. Okay, that's why I'm initializing my LLM again. Now previously I got some questions, I think remember. So this is the questions I got. Okay, these are the questions I got. If I show you beautifully, so what I can do, I can split with the help of /n. So it will give me line by line everything. Now this is the question list. See, so this 10 question I got. Now I have to generate the answer of this 10 question. Okay, with the help of large language model. Now for this, let's create a retrieval QA. Okay, question answer, let's say chain, because inside chain we are having different chains. I think I told you. Now I'm using retrieval QA chain. This chain I already used in my vector DB. I think You remember? Let's create it. Now let's initialize my QHN. So here you have to give the large language model first of all. Now you have to give the chain type is equal to stub because it's a QHN. Okay. Now you have to give the retriever object. That means your vector store. That means you are connecting with your large language model right now. See, LLM, you are connecting with the vector store. Okay. For this, you have to write this code, vector store as retriever. That's it. Now this is going to give you one chain. Now you can give the, let's say, question and you can get the answer. For this, I written a for loop here. See what I'm doing. Whatever question list actually I'm having, I'm looping through it. That means I'm taking all the question one by one. Okay, you can see. Then I'm printing it. Then I'm generating the answer. You can see I'm calling this chain run question. That means I'm giving the question. It will give me the answer. This answer actually I'm also printing. After that, I'm opening a txt file. Inside that, I'm just saving it. Okay, inside that, I'm just saving it. That's it. As of now, inside a txt file, I'm saving it. Going forward, inside a CSV file, I have to save it. Okay, this is the idea. Now let me execute. See, first of all, this is the first question. It is generating the answer. See, this is the answer. Okay, second question, it is generating the answer. Third question, answer. Fourth question, answer. So that's how it will generate for all the questions. Let me show you. See, beautifully it is generating. So we have created one amazing application, guys. Now we have to convert it the modular coding. There's the idea. Now see, all the answer I got. And if you read the answer, guys, if you open your text editor and if you read the answer, it's pretty good. It's pretty good. If you see that question and answer, it's pretty good. Now you can use as it is. As it is for any kinds of exam, any kinds of interview, you can prepare. It's amazing, right? Okay, so this is the entire actually, let's say, notebook experiment of our project. Now let's try to convert everything in a modular coding. Modular coding is, I just need to write everything in a function. That is the idea only. Okay, I'll refer the same notebook only. I'll copy paste the same code, but I'll write everything in a function. Okay, there is nothing new I'll be doing. So let's start the modular coding. So guys, now let's start the modular coding. But before that, let me show you this answer.txt. Now see, inside answer.txt, it has saved everything, all the question and answer. But again, it's not readable. So next time what I will do, I'll save everything in a CSV file. In one column, I will add the question. In another column, I'll add the answer. Okay, that would be more readable. So what I'll do, guys, now let me close everything. So left hand side, I'm going to create a folder and I'm going to name it src. Okay, src. Because this is going to be my source folder. Inside that, I'm going to write some helper related function. That means if you open up any kinds of, let's say, real-time implementation of any kinds of package or any kinds of project inside Python, let's say, if I open this one, Keras, GitHub, you will see that they have also created this kinds of folder structure. See, this is the Keras. Now, Keras is also using this. See, it is having one root folder Keras. Inside that, they are also having the source src. And inside src, they have created all the, let's say, utility related functionality. That means whatever functionality they need, let's say activation function, application, backend, callbacks, they're writing everything here and they're integrating in the endpoint. Okay, it is also having some endpoint. See, API gen, this is the endpoint, and they're importing it here. If you open it, any kinds of endpoint, they're importing it here. Okay, this is called actually modular approach. That means instead of writing everything in just one file, we have to create a separate file, separate function, and whenever I need it, I'll just call it. Okay, from that particular, let's say, a helper function. This is the idea. So inside src, I'm going to create a file called __init __.py. Okay, this is the constructor file because this folder would be considered as my local package right now. See, this is the modular concept, guys. This modular concept I already explained in my Python session. Okay, so I think you know. So guys, this is our YouTube channel. So here, if you go to the playlist section, I already created complete Python course. So here I already explained about modular coding, everything. What is this constructor file? What is modular coding? How we can write any function in any other file, how we can import it in the endpoint, everything I have explained. Just try to go ahead and watch that one because modular concept is required here. Okay, I'm expecting you are already familiar with this kinds of Python concept. Fine. So you can also see the master OP actually playlist. So there also I have covered lots of advanced topic related Python. So that's why I'm creating this constructor file because this folder would be considered as my local package right now. Okay, and inside that I'm going to create a file called helper.py, and I'm going to create another file called prompt.py. Okay, prompt.py. So inside prompt.py, I'm going to mention my prompt. So let me show you. So the prompt actually I showed you in my Jupyter notebook. So here I'm going to just define. See, this is my prompt template, first prompt template, and this is my define prompt template. Nothing new, guys. I'm just copy pasting from my notebook only. See, the same prompt I just copy pasted because prompt is a changeable. Okay, it's a changeable. It's a static one. People can change anytime. So that's why I've written inside prompt, let's say file. So user will open the prompt file and there actually they will change. So that they don't need to open the actual code implementation, and inside that they don't need to change. Okay, I don't need to hard code these are the value. That's why I kept this separate entity. I hope it is clear now. Now let me close it. Now inside helper.py, see whatever code I have written so far. That means I loaded my documents, I performed the chunking operation, then I created the questions. Okay, these are the thing I'll be writing inside a function only. So inside helper, I created two function. First of all, you have to import all the required package you need. I think you remember these are the packages actually I need. I loaded in my notebook. Then I need to load my I need to load my OpenAI API key and I have to set as environment variable. I think you know, got it right. Now the first function I have written called file processing. Same thing guys, if I show you the same thing I'm performing here. First of all, I'm loading my documents. I'm adding all the, let's say, content inside one variable. I was performing this one. Chunking operation. First of all, I was doing with the help of 1000 token. Then next time I was doing with the help of, first of all, I was doing the 10,000. Okay, 10,000 chunk. That means one chunk I want to consider as 10,000. Then I was doing for the 1000. That means the same experiment I did here. Remember, same experiment. See, same experiment. I just written inside a function only. That's it. That is the difference only. So this is called actually modular approach. You can also create a Python class, but as of now, it's a very, let's say, a small implementation. That's why Python class is not required. But if you see the actually very big implementation, any ML project or deep learning project, you will see that there I've written like lots of class. Let me show you. So inside US Visa, if I open the components, let's say data ingestion, you can see I've written a class that time. Okay, so class is required because you can see lots of function I have to handle. And whenever you are having lots of function, lots of method, that time you can write a class. But here I don't have actually lots of method. I only have 1 to 2 method. Okay, that's why I've just written directly a function, not a class. Okay, this is the idea. So that's how you have to design your own project, whether your project size is very huge or not. If it is huge, try to maintain the class, otherwise try to maintain the function. This is the difference only. So if you see any kinds of GenAI project, so most of the time actually we create, let's say, inference on top of large language model, we create a RAG application on top of large language model. Okay, that's why the code implementation is not big that much of. But whenever actually I'm creating any ML project, DL project, there actually we are training our custom model. That time actually lots of method we have to handle, very big code base we have to handle. Okay, that's how we need class concept. This is the idea. Now you can see guys, I will get my object. Okay, object related my chunking. You can see it will give me document question gen. That means after performing the chunking, and document answer gen. Okay, both actually it will provide. So question gen is nothing but you can see I'm converting to the documents this question, whatever questions actually I was getting. So this is the document question gens. That means after converting to the documents, whatever documents I'm getting, this is my document question gen. And after doing the chunking, this is my document answer gen. So this question generation and this document I need for the answer generation. Okay, the same thing I perform in my notebook. I think remember. See, first of all I was using document question gen just to generate the question. Okay, then I was using document answer gen just to generate my answer. Okay, I hope it is clear. So this function I have created guys. Now the next function I have created my LLM pipeline. That means I will be using my large language model. I'll be creating the vector embeddings. Okay, so everything will happen inside this function right now. LLM pipeline, first of all, I'm calling the file processing. That means this function inside that whatever file user is giving, this file would be processed and it will give me document question and document answer gen. I'm creating my large language model, creating the prompt, both prompt actually. That means my prompt question as well as the refined prompt. Okay, both I'm creating. Then I'm first of all creating load summarize chain. I think remember load summarize chain I was creating. Okay, this one. So it will give me the question. It will give you the question, and I was creating the vector embedding after that. Vector embedding. Then I was creating the vector index. You can see vector index. Then I was creating the retrieval keyway that time. Okay, it will generate you the answer. That means question answer. That means here you will get answer question generation chain and filtered question list. Okay, both actually will get. So these two function I prepared here. Now let me save. Now let me create the endpoint. So here what I will do, I'll create a file. I'll name it as app.py. Okay. Now this is going to be my endpoint. So inside that I'm going to call this function actually, this LLM pipeline. Because inside LLM pipeline, I'm calling my file preprocessing. That's why I don't need to call separately. So let me open it up. But before that, let me initialize my Fast API related code. So if you go to the Fast API documentation, guys, you will see this is the start our code. That means this is the demo code they will also give you. So these are the library you have to import one by one. Okay, then you have to initialize the fast API. So how to initialize the fast API, guys? So that's how you can initialize the fast API. Okay, see, this is the code to initialize the fast API. Now here you have to create two folders, static and templates. Inside that you have to create the index.html file. So inside template folder you have to create a index.html file, because index.html file would be your home page. Okay, that means the user interface. So you need some HTML code. Let me show you. I already created. So guys, as you can see, I already created one template folder. Inside that I created a HTML file. Okay, now see, inside that I have written already HTML code. Okay, that means my front end part of my application. And how I created, again, I referred that Bootstrap website. I think you remember. I also used the Bootstrap website. If you don't know about HTML code, it's completely fine. You can skip this part. You can use, let's say, any other framework, let's say Streamlit on. And see, this HTML creation would be done by the front-end developer. As of now, just to beautify this project, I created the HTML, okay, from my end. That's the idea. And there is another folder I created called static. Inside in static, I created two folders called docs and output. See, whatever documents user will upload, that PDF, it will save inside documents folder. And whatever output you will get from the, let's say, application, that means the question and answer in a CSV format, because you can see I've imported the CSV, it will save inside output folder. And from output folder, actually, I will get that particular, let's say, CSV output. Okay. And inside documents, it will store the PDF. That's the idea. Now, this is the fast API code, guys. Fast API will handle each and everything. Now, I also need to import this one. That means my LLM pipeline. Let's import. So it is available inside, I'll call it from, let's say, src dot, let's say, helper import LLM pipeline. So it is inside helper. I need to import LLM pipeline, because inside helper, I have this LLM pipeline. Okay. Now see, if I am importing like that, from src helper import LLM pipeline, that means src is now considering my local package. And if I want to use src as my local package, what I have to do? I have to create one file called setup.py. Okay, setup.py. So this is the modular coding concept, guys. Again, inside setup.py, you have to write some setup related code. Let me show you. So this is the code, guys. Setup tool. First of all, give the project name, version, author name, author email, package, and install requires. That means this find package will try to find, okay, wherever this constructor file is available, this folder would be considered as my local package. Now you can see constructor file is only present inside src. That means src would be considered as my local package. Now see, if I show you pip list inside my environment, see, src is not mentioned. Src is not a package. Okay, see, src is not a package. But whenever I will install it, whenever I will install this setup, you will see that this src would be considered as my local package. That means there would be a package name called generative AI project. You can give any name. I've given generative AI project. Now let me save. And to install it, in the requirements, you have to add one more line called -e space dot. Okay. So this -e space dot will look for the setup.py and it will install this package. Okay, let me show you. Now if I again run, let's say pip install -r requirement.txt. See, this would be installed as my local package right now. Done. Okay, now see, some egg info file would be created. Okay, whenever this egg info file is created, that means this setup is successful. Now if I again open up my environment, let's say pip list. Now see, there is a package it has created, generative AI project. Okay, now see, it is my local package right now. That means this src would be considered as my local package. Now I won't be getting any kinds of error right now if I'm importing like that. Okay, so this is called actually modular approach. I think you got it. So here, first of all, user will upload one PDF. For this, I have written a function with the help of fast API. So this is the function. So there is a route called upload. User will upload one, let's say, file, and this file would be saved inside my documents, inside statics documents. Okay, it will save. Now there is another function I will create called get CSV. That means the complete results. Okay, I want to save as a CSV file. So this function will help me to do that. That means the file actually I'll be receiving here. This file I'll give where in the LLM pipeline. And LLM pipeline, what it will do, it will pre-process. It will create the, let's say, prompt and everything. Then it will give me the that means chain, entire chain. Okay, and that chain actually I will utilize here. You can see. So you can see I'm getting the entire chain, and whatever question list actually I'm having. Okay, question list. I'll pass the question inside my chain, and it will give me all the answer. And this answer actually I'll save inside my CSV file. You can see right row. Okay, CSV writer right row. And for this actually I'm using CSV package. You can see CSV package. Very simple code, guys. Only have written inside a function only. You just need to go through this code. You will able to understand. Okay. Then I need another function, guys, called chat. So this particular function, what it will do, it will load the output file, that means the CSV file, okay, and it will show, it will return you, okay, it will return you. That means you can also see the complete PDF, okay, in the UI. Let me show you how this application will look like. So now let me execute my first API code. See, this is the first API code. If you can run app, this is the local host and this is the port number 8080. Okay, now let me save and now let me execute. So I'll open up my terminal. So python app.py. Now see, it is running. Let me give the allow permission. Now I'll go to my Google Chrome and here I'll search for localhost 8080. See, this is the user interface, guys. Okay, now here you can upload a file. First of all, let's say I'll upload this file inside data. Let's say I will upload this SDG. First of all, this sustainable goal development, and here I'll generate the question and answer. Let's see. It is generating. This is the user interface we created, basic user interface. Now see, it's loading. And how this loading is happening, animation is happening, because I written everything inside HTML code. So guys, you can see I got the output. Now left hand side you can see it has rendered my entire PDF. Okay, the PDF I uploaded, and right hand side it has given me the CSV download. And now see, if I click here, it will download the CSV file. See, QA CSV. Now let's open the CSV. How I can open? Let's open it here. So I'll open it. See, this is the CSV. I don't have Excel right now, guys, in my system. That's why I've opened in a VS Code. You can see this is the question, this side, and that side actually I have the answer. You can open in a Excel viewer. You will see that it's a beautiful format I have just stored. Okay, so that's how actually things are happening. Okay, now I think you got it. Why we have written these are the function. So this function will help you to render your PDF documents, as well as it will give you the download option, okay, to download this particular PDF. Now let's upload another PDF. Let's say I will upload this statistics one right now. Now let's generate again. So guys, as you can see, I got the results, and this is my PDF I uploaded, and let's download the QSSB as well. See, this is the correlation answer and question I got. Fine. So yes guys, this is the project. Actually, I hope you liked it, and this is like very interesting project, guys. If you develop it, I will feel like it's like very interesting. Going forward, we'll be also implementing lots of projects, no need to worry. So in the next video, we'll be implementing another amazing project, very interesting project called chatbot for any website. That means, let's say I think you saw website chatbot. If you go for any kinds of website nowadays, they're having their chatbot integration with that. Okay, so if you ask, let's say, some question related about the website, about their, let's say, product and service, it will able to give the answer. So that means they're replacing the human behind it. Previously they used to, let's say, use one human. They used to receive the chat, they used to give the reply, but nowadays they have added the chatbot there. Chatbot can handle all the answer. If you go to any of the website, you will see that. So we'll be implementing these kinds of application. That means the custom website chatbot, it will only work based on our website data, not any other, let's say, question and all. Fine. This is what actually we'll be implementing, and this is kinds of RAG based application we'll be creating. Okay, that means we are using our custom data. On top of that, we are adding our, let's say, like a large language model. Large language model will try to refer that data to provide you the answer. Fine. So in this implementation also, I am going to use LangChain large language model. Even we'll be also using something called vector database. Okay, with the help of that, actually we'll be implementing this entire application. But see, this application would be a little bit advanced, because here we'll be creating something called RAG based system. Okay, like retrieval augmented generation. This is the basic RAG. So here we'll be using our custom data. So custom data wise, actually we're going to use our website data. That means we'll be giving some website, okay, website URL. So my LangChain will automatically fetch the information from the website itself, and this data actually I'll give to my large language model. That means my LLM would be connected with this data, and if you're asking something related about this website, okay, it will give you the answer related that. Okay, so this is the application we'll be implementing. So first of all, let me show you the architecture, like how we are going to develop this project. Then I think this part will be clear. So before showing you the architecture diagram, guys, let me show you one thing. So let's say if I want to open any kinds of website, let's say I will open this openai.com. Okay, this one, openai.com. So this is the openai.com website. Now see, if I want to see the, let's say, XML page of this website, so what I can do, I can give this particular, let's say, route here. So /sitemap sitemap.xml. So if you open any website and if you give /sitemap.xml, it will show you the entire structure of the website. Let me show you. So guys, here you can see this is the page actually I got. Now see, inside openai.com, okay, inside openai.com, whatever, let's say, content you are having, whatever content, whatever sub pages you are having, all the information is coming here. You can see, if you just see it carefully, so it is having different URL, okay, different URL for the different tab. Let's say research, for research actually it is having one URL. For GPT 4.40 it is having one URL. For safety, company, see company, I think I saw here. So see, this is the company one. Okay, this is the company one, you can see. Okay, company one. So I think I showed you the company. So see, this is the company URL. So that means it is having all the information, all the data, whatever content you can see in this website. Okay, everything is visible now in this XML page. Now what I have to do, I have to use this concept to extract the data. That means I'll be using LangChain data loader. So inside LangChain actually we are having website loader. With the help of that we can easily load these are the content. So I'll tell you how we can extract the information. So this is the things actually we'll be doing. Now let me show you the architecture diagram, what we are gonna perform here. So let me open up my Blackboard. See here, first of all, I told you we'll be using website URL. Okay, website URL. So from website URL, what we'll do, we'll just get this sitemap, sitemap.xml. Okay, this page. And from this page actually, we'll be getting different sub pages as well. Let's say page 1, then page 2, page 3, okay, and so on. That's a multiple page actually we'll get from here. Now what I have to do, from each and every page I have to extract the documents, that means the data. So it should be docs1, let's say docs2. Then after getting all the documents, we'll be using one embedding model. I think you know why embedding model, because I have to convert all the documents to the embedding representation. Okay, so I'll pass all the data to the embedding model. Okay, an embedding model will try to return embedding, vector embedding. So you will get different vector embedding, let's say 0.2, 0.3, 0.5, and so on. Let's say these are the vector representation as of now, just try to consider. Then with all the embeddings, what I have to do, I have to create one semantic index. Okay, semantic index, I think you know, build semantic index. Okay, build semantic index. Then this semantic index, that means this embedding, I will store where? I will store to the vector database. Let's say this is my vector database. So in this case, actually, I'm going to use FIAS. You can use any other vector DB. Let's say this is vector database. Okay, I'll be using FIAS. You can use anything. You can use, let's say, ChromaDB. You can use Pinecone. I'll tell you how to use Pinecone ChromaDB later on. I will also tell you. Now what will happen? So user will ask question. Okay, user will ask some question about the website, and this vector DB will return some ranked results. Okay, I think you know what is ranked results. Ranked results. Okay, rank results I'll get. But what I have to do, I have to initialize my large language model, because with the help of LLM only, I'll able to get the correct response. So what I will do, I'll pass this rank results to my large language model as well as this query also. Okay, and this LLM will give you the actual response. Okay, actual response. So this is the complete idea. Okay, this is the complete architecture of our application. Okay, and this is called actually RAG. Okay, RAG. That means retrieval augmented generation, because here we are integrating our custom data. Okay, and we're integrating our large language model with that data. That means this is called actually knowledge base. Okay, knowledge base right now. Okay, entire knowledge base. So now let's open up our Colab notebook and try to install everything, and let's implement this project. So guys, as you can see, I opened up my Colab notebook. So first thing, just try to change the runtime. So here runtime, just keep it as CPU only, because here we'll be using OpenAI model. But if you want to use, let's say, any other open source model, that time you can use GPU. Okay, that time. So as of now, let's keep it CPU only. So later on, I will also show you how we can use a new open source large language model. Okay, now let me connect this notebook. So here, first of all, you have to install some package. So you can see I'm installing LangChain community, PyPDF, then a sentence transformer, okay, OpenAI, TikTok, and these are the things. So these are my dependency package actually I need. So let me install all of them. So some of the package actually you don't need. I just written additionally, because later on this project I will show you how we can implement with the help of open source large language model. Okay, that time actually this sentence transformer is required, because if I want to use any, let's say, open source embedding model, that time this is required. So as of now, let's install everything. Then apart from that, I also need to install some more packages. So tick token, fire CPU, and unstructured. Let's say if I want to load the website now, website data, that time I need this package unstructured, because it's unstructured data. And again, I'm going to use Fire's vector database. Okay, that's why Fire CPU I'm installing. So let me install all of them. Then I also need to install NumPy and NLTK. Okay, so let me install, because these are some dependency packages. If I want to extract the information from the website, so LangChain needs, these are the dependency. Okay, so that is why actually we are installing everything. Now see, after installing this NumPy and LTK, it will tell you restart the session. So let me restart the session. So it will restart the session. Then after that, we'll be importing all the necessary library we need. You can see I'm loading unstructured URL loader from LangChain. So with the help of unstructured URL loader, we'll be loading this data. Okay, here we'll be giving the URL, website URL. It will automatically extract all the information. And we'll be performing the chunking. For this, we are using character text splitter. OpenAI embedding will be using just to convert my data to the embedding representation. We'll be using OpenAI large language model, GPT 3.5 Turbo. That's why we are using chat OpenAI. Fires, this is the vector DB, retrieval keyway with source chain. That means it will create the keyway object. That means the chain object. Okay. And Hugging Face embedding, as of now, I don't need. I'll just try to remove it. Okay. Later on, I'll tell you how we can use the Hugging Face as well. Now let me import all of the packages. So it's working fine. There is no error. Now let me download this two thing like PUNKT, and you have to download another thing, Average Perceptron Tagger. Okay. So this one you have to download from the NLTK. So let me download. Then after that, I will set my OpenAI API key, because here I'm going to use OpenAI large language model. Definitely you need the key. Now I'm going to pass different website URL. So now you can see I've just collected different website URL. Let me open all of them. Let me show you. So these are the website actually I'm going to refer. So this is one blog website, Medium website, you can see, and the content about paper review, Llama 2, Open Foundation, fine-tune chat model. Okay. Now if you just read it, you will see lots of content related Llama 2. Okay. Now there is another website, Databricks I'm using, introducing MPT7B, a new standard for the open source community usable LLM. So this is another large language model. Now you can see the information is written about this large language model. That means we'll be extracting these are the data, and we'll be creating one chatbot. It will provide, and that chatbot actually will be able to give the answer related. These are the topic. Okay, the topic actually you have created. Let's say Llama 2, then MPT7B, then stability.ai. Okay, so this is another website. Then you can see Vicuna. So this is another website. Okay, so these are the information actually I want to see. So I have given all the website link. So here you can pass any kinds of website link. You can pass any kinds of website link. Let's say you have one website, your own website. You can give the website link here. So this will automatically extract your website information, and you can create your website chatbot. Okay, on top of it. This is amazing. Now let me initialize the URL. So it supports actually multiple website URL. It's not like that it only supports one URL. No, multiple URL you can give here. Now let me extract the documents with the help of unstructured URL loader. Inside that you have to pass all the URL, and it will automatically extract all the information. Let me show you. Now if I print the data, all the information it has extracted from all the websites. See, okay, amazing. Now if I show you the length, you'll see that 4 documents it has written. Why 4 documents? Because I have given 4 website. 1, 2, 3, 4. That means 4 website information I'm having right now, and this is in the document format. Got it? Because I already told you if you're loading anything with the help of LangChain, that should be document format always. So now I think this part is clear. So we have extracted the content successfully. Now what I have to do, I have to create the chunks. Okay, I have to create the chunks, different chunks. You can see these are different chunks. So I think I forget to mention this chunking here. So it should create a chunk. Okay, chunk. Okay, all the chunks. That means it will create all the chunks. These chunks actually I'll give to the embedding model. Okay, now let me create the chunk here. So to create the chunks, actually I'll be using character text splitter. See, these are some repetitive code. Again I'm using. Previously I also already taught you what is character text splitter, what is chunk size, what is chunks overlap. Everything I taught you, even in the vector database session. So this is very much important session, guys. Just try to complete that session first. So you can see character text splitter, separator is equal to /n, because you can see /n is there. Okay, sometimes So slash would be the separator. So here slash n would be the separator. It will separate by slash n. Now chunk size 1000, chunks overlap 200. Okay, now let me create my text splitter. Now inside that I'm going to provide my data. Now it will give you chunks. Now let me see how many chunks I got. So here I got 86 chunks. If you want to see them, simply just print like that. Let's say I want to see the first chunks. This is the first chunks. Let's say I want to see the second chunks as well. I can also see that. See, second chunks as well. And you can see it is also giving me the source URL, like from which URL it is giving you the data. Okay. Now we'll be initializing the embedding model, because you can see the architecture. Now I have to download the embedding model, then I have to convert everything to the embedding representation. So let's use the OpenAI embedding. Now let's test whether it is able to convert to the embedding representation or not. So here I'm calling the embedding model and I'm passing one sentence, hello world. So it should give me the embedding results. Let me show you. And the vector dimension is 1536. Okay, this is the dimension. Now if I show you the numerical representation of this sentence, so this is the numerical representation. That means this is my vector embedding. Okay, so we'll be following the same concept. Now let me convert my text to the embeddings. But for this, actually, I'm going to use FAISS vector database, because whatever embeddings I'll be generating, I'll store in the FAISS. Okay, FAISS vector database, and FAISS is a local vector database. I think you know. So here I'm giving my text chunks and my embedding. Okay, embedding model. Now guys, see, this is my semantic index right now. Okay, this is my semantic index. That means my vector index right now. Okay, now what I have to do, I have to connect my large language model. So let's initialize my large language model. So here I'm going to use OpenAI large language model. By default, it will use GPT 3.5 Turbo. Now let's test our large language model, whether it is able to generate or not. So here I've given a prompt. Please provide a concise summary of Harry Potter book. Okay. Now if I execute, it should give me the summary of Harry Potter book. See, this is the summary of Harry Potter book. Okay. It has given me. Great. That means it is working fine. Now with the help of LLM as well as my vector database, I have to create my chain. So for this, I'll be using retrieval keyway with source chain. Okay. I think I already imported from the LangChain. And inside that, I'm passing my large language model as well as my vector database. Okay. And this will give me the chain. Now inside chain, actually, I can ask any kinds of question right now. See, question is equal to how good is Vicuna? So here I'm asking related Vicuna. Okay. This particular Vicuna. So Vicuna data I have already given to my large language model. I think remember it is already available inside my knowledge base. Now it should give me the answer. Okay. Let's see. Okay. Now if I want to see the answer, so I'll just call result. Inside that, I want to only extract the answer. Okay, now let me show you. See, Vicuna has shown competitive performance compared to the others model like Stanford Alpha. Okay, that means if you read it, okay, if you read this documentation, you will see that that is what actually they are telling. That means amazingly, it is able to give me the answer right now. Great. Now let's ask any other question. Let's say the next question I'll be asking about Llama 2. Llama 2. How does Llama 2 outperforms other model? Okay, let's ask this question, and whatever answer I will get, I'll also print it here. Now see, Llama 2 model outperform other models in various categories, including MPT models and similar size and so on. Okay, now see, it is referring to Llama 2 right now. Yeah, Llama 2. Great. Now let me ask another question. So I'll be asking about MPT, this one, MPT 7B model, and whatever results actually I will get, I'll just showcase it here. See, again, I got the amazing response. Okay. Now see, it is referring my website data. That means my custom data, not any other data. Okay. This is the main thing here we have developed. Now, if you're asking any other question, let's say, tell me about India, it won't be giving you the answer, because here we have created the custom chatbot. It will only refer my data, the custom data I have given. Now here I can create a while loop and I can continuously ask the question. Okay. So you can see I'm taking the prompt from the user, and if it is exit, I'll do the exit operation. Otherwise, I'll continue and I will keep on asking the question and it will generate the answer. Okay, let me show you. See, it is asking the question. So what I can give the same prompt again, copy, and here I can pass. And let me press enter. Now what you can do, guys, you can convert this project to the web interface. That means web application. I think I showed you how we can use different, let's say, Python package like Flask, then Fast API. So this should be your task, guys. Try to create one web application, at least basic web application. Their user will give the prompt and it will provide the answer. Okay, that's it. Now see, it has given me the answer. Okay, now again, it is asking another question. Now let's say if I give exit, it will exit the application. sorry, it should be exit only, but I have given exit parenthesis. Now see, if I'm giving this prompt, it is telling that text provided does not seems to be relevant to the questions. Now see, this question actually doesn't have any context, whatever knowledge base it is referring. That's why I told you, it won't be able to give you any other information. Now if I give exit right now, it should exit the application. See, okay. So that's how we can create any kinds of custom website with the help of our custom data. Now what you can do, you can open up any kinds of website and you can implement this project, guys. Okay, and later on I will also tell you how we can use the open source large language model. Okay, and with that, how we can create this application. So with that, guys, thank you so much for watching this video, and try to complete that task. Try to convert this application to the web interface as well. So guys, as of now, we have worked with OpenAI based large language model, which is nothing but GPT. Okay, so we have seen like how to use GPT series to build this kinds of generative AI application. And one thing I think you have seen there, like GPT is not free, so you need to pay for it. So whenever you are using OpenAI API, you need to pay some money, okay, for that. But let's say if you don't want to spend this much of money here, so what you can do, you can use something called open source large language model. So in the market, actually, we have lots of open source large language models are available. So if you are using it, so you don't need to pay any money for this. So you can directly use them, and it is completely open source and for commercial use cases as well. You can either do research on top of it. You can either create a commercial application on top of it. It's completely free for you. Okay. So in this video, actually, I'll be discussing about like open source large language model, like what is open source large language model. Okay. And what are the open source large language model we have, and from them actually I'll be discussing some of them, like most popular used open source large language model, and it is like very powerful. Okay, and I will also show you how we can like build generative AI application with the help of these kinds of open source large language model. Okay, so it would be completely amazing video, so make sure you are watching this video till the end. Don't skip any part of this video, otherwise you might get confused for sure, right? So yes guys, let's start with our video. So guys, here we'll be learning like most used and most popular very powerful large language model. Here you can see we have Meta Llama 2. So this is the model from Meta AI. I think you know, like we also call them Facebook. So they have introduced this model called Llama 2. It has another version called Llama 1, but Llama 1 is for like research purpose. They have given the permission, but you can't use Llama 1 for the commercial use cases. So for this, actually, they have open sourced this Llama 2 model. So you can either do research on top of it, either you can create commercial application. It's completely fine. Then from Google side, we have another large language model called Google Palm 2. So this is one of the very powerful large language model. Okay, and it is completely open source and free. Then we have another like most used large language model called Falcon. So Falcon has lots of variant. I'll show you like whenever I'll be discussing like Falcon, I will tell you like what are the variant it has actually. So it has different parameter variant. Okay, even Meta Llama 2 has different variant. Okay, I will tell you whenever I will discussing about this Llama 2 and all. Okay, so these are the most used and most popular large language model. I'll be discussing like how we can use it, okay, and how we can create generative AI application on top of it. I will be discussing each and everything. So apart from that, we have lots of large language model are available in the market, and it is completely open source. So guys, I found one GitHub repository. So there actually that guy collected lots of open source large language model list, and he has created one readme file there. So I'll show you that one, like what are the open source large language models are available in the market. So if you also want to explore that one, you can also go ahead and check it out. Okay, so if you learn like how to use Meta Llama 2, Google Palm 2, Falcon, okay, you will also able to do that. Okay, so guys, as you can see, this is the repository, and the repository name is like OpenLLMs. And here if you see, we have lots of open large language model are available. You can see T5, EUL2, then Pathia, Dolly. Okay, then here you will see like Bloom is there, then FastChat, then MPTP 7B. This is the 7 billion parameter. Then Falcon, I will be discussing about Falcon. So as you already saw, like in my topic, I will be discussing about this Falcon. Okay, so even that, actually they have also shared this paper, blog, and everything. Okay, if you want to learn, you can open it, and all these steps actually will be getting. Then Llama 2 is also there. Okay, then Mistral 7B also there, then Google Palm is also there. Okay, so here actually we'll get all kinds of open source large language model. Okay, and if you see here, it was committed 4 days ago, so it is like very update repository. So here you can check it out if any large language model is coming in the market. So here actually we'll get all the list and all. And apart from that, you can also search from your side. Let's say if you are exploring any other topic and all, so you can search and you can learn about. Okay, so yes guys, this is all about our large language model, open source large language model. I think you got it. Okay, so guys, we don't only have the option using like you can say OpenAI GPT model. Apart from that, we have these kinds of open source large language model we can utilize. Okay, so I personally prefer this kinds of open source large language model because this is like very powerful. So it can also work like your GPT 3.5 Turbo. Okay, so it's like very powerful model. So using these are the model, actually you can solve a very complex problem statement. Even you can create a very beautiful generative AI application. So why you need to pay, right? But if you also want to pay, because see, GPT is like very good model, I know that, but again it's like completely hosted like API. So you can directly call the API, you can hit the model, you can get the response. So this is the beautification they have created in their website. But apart from that, let's say you don't have money and you don't want to spend money on top of these kinds of model, so you can use this kinds of LLM model and you can create your application on top of that. Even you can also fine tune them. Okay, so this is the beautification of these kinds of large language model. So in future I will also show you how we can fine tune these kinds of large language model on top of our custom data, on top of our custom use cases, and how we can use it. Okay, so fine tuning is not required unless and until your data is like very complex and it is like very private data. So that time you can fine tune them, but most of the use cases can be solved using these are the model. Okay, so yes guys, now let's go back and try to see like what are the things actually we'll be learning from this video. So guys, in this video actually I'll be discussing like the introduction to Llama 2, like what is Llama 2 and all, like who has published this Llama 2, like what are the variant actually Llama 2 has and all. Then I will show you like how we can run this Llama 2. Okay, I'll show you like some difficulty level, like how why we can't use the actual Llama 2 model, okay, hosted from Meta AI. So which model actually I'm going to use it. So how to execute this Llama 2, okay, I'll be discussing about on Google Colab, because you can also do it in your local machine as well, but I will do on Google Colab because Google Colab would be pretty much good environment for me, because there I will already have lots of predefined library setup, right? Then I will show you like how we can use this Llama 2 with LangChain, because nowadays actually people uses this LangChain's framework, okay, to create generative AI application. So I'll also show you how we can use the LangChain, okay, with this kinds of Llama 2 open source large language model. And at the end of the video, I will also show you how we can build generative AI projects using Llama 2. So there actually will be implementing one project, so very interesting projects, okay, with the help of this Llama 2. Even I will be using LangChain there also, okay. Then we'll see like how we can integrate open source model with this kinds of framework LangChain, then how we can create these kinds of generative AI projects. So it would be completely end-to-end video about this open source large language model. Okay, you'll be learning each and everything about open source large language model, like you will be knowing each and every part of this Llama 2 and all. So make sure you are watching this video till the end. So this should be my request guys, and also try to practice with me, okay, in live. Whatever things I'm writing, you just also try to write with me. Even all the code and everything will share in the resources section. From there actually you can get it. So first of all, let's discuss about Llama 2, and in the next video, I'll be discussing about Google PaLM and Falcon. So guys, if you search on Google like Meta Llama 2, so you will able to see this website, the first website, okay. So this is the website of Llama 2. So here actually they have published this Llama 2 documentation and all, like how we can use it and all. And this documentation will give you the entire idea about Llama 2, like what is Llama 2 and how many variants actually it has, okay. Even the benchmark also you will able to see. So guys, here if you see Llama 2 is nothing but it's a next generation open source large language model, and Llama 2 is available for free research and commercial use cases, as I was discussing about. And if you want to access this Llama 2, so they have given the link here. So here actually you need to fill some information like your name, email address, then country and organization. So these are the basics form you need to fill and you need to submit. So after some time actually they will give you the permission, because see, you can't directly use this Llama 2 model. So for this you need to send some information of you. Then after some time actually they will give you the permission. Okay, I also applied this request form. So after let's say 30 minutes or let's say 1 hour, you will get the access for sure. Okay, so I will also show you one alternative. So if you want to do it right now, so one guy actually cloned this complete Llama 2 model, okay, in his you can say Hugging Face repository, and it is completely public, okay. So you can use that model if you're not getting permission. And once you got the permission, you can use official version of the Llama 2 model. Okay, so I'll show you like both option how we can do it. So for me, I already got the access from this Meta, so they have given me the access. I'll tell you like how to apply for the access and all. Okay, so as of now, the experiment actually I'm going to do, like how we can execute this Llama 2 model. I'll be using something called quantized model, because the actual like Llama 2 model you can't execute on Google Colab, on free Google Colab. So for this actually you need good instance. Okay, like good instance means like you need powerful machine, you need more RAM. Okay, you need more memory there. But if you are using free version of Google Colab, and if you're using your local system, so there actually you can't load this model, so it would be very hard for you. So better we'll be using some quantized model. I think you know what is the quantized model. So quantized model is nothing but it's a quantized version of the actual model. So they have just compressed the model, okay, with the integer encoding, and they have proposed this model, and this model size is a little bit less, so we can load this model in our memory, okay, in very easily. I will tell you like how to use a quantized model and all. Okay, so guys, here if you see, Llama 2 was trained on 40% more data than Llama 1. Okay, because I told you there is another model called Llama 1, and Llama 2 trained here Llama 2 trained actually more than 40% data than Llama 1, and it has actually double context length. So, basically the context length is like double, okay, than your Llama 1. And see, these are the Llama 2 variant. Actually Llama 2 has 7 billion parameter, and another variant has like 13 billion parameter, and another variant has 70 billion parameter. And this is the pre-training token, you can say. So they have used True Trillion token to train this model. And here if you see, this is the context length, so it's 4096, but whenever I was talking about Llama 1, so it has actually 2000 something context length, but it is like double, okay, double than your Llama 1, and this size is around 4096. And here if you see the training strategy, so they also use supervised fine-tuning technique on top of it. Then they also use something called human preferences. I think you know like how we can train these kinds of large language model. Okay, what is the idea and all about. Basically this is the strategy we follow in every large language model. Okay, then they have applied something called reinforcement learning to understand the human input, to understand the human you can say prompt. Okay, so they have used this strategy to train their entire model. And Llama 2 pre-trained models are trained on 2 trillion tokens. Here I already discussed, and have double context length than Llama 1. Its fine-tuned models have been trained over 1 million human annotation. Okay, so 1 million human annotation means they have applied this supervised fine-tuning technique. So they have created one chat use cases. So basically, see, whenever I'm giving any input, let's say just fix this code for me, or let's say generate you can say a Python code for me. So these are the chat actually I'm giving. So with respect to that, actually, what is human annotation? Human annotation means like see, whenever you are giving these kinds of prompt, so one human will be replying the actual thing here. Okay, that's how your model will be learning. Let's see, if you're giving any random message, let's say hi, how are you, fine, okay, and all. So one human will chat with you, like manually they will chat with you. So we call them human annotation, and with the help of this data, actually we train our actual model, and we create these kinds of very powerful large language model, right? And this is the benchmark, as you can see. So here we have lots of model. We have MPT 7B, then Falcon 7B, and we also have our Llama 2 7B 13B, and we also have 65B and 70B. Okay, so here we see these are some benchmark data, and this is the performance of the model. As you can see, MPT 7 billion, this was the accuracy, 26% accuracy. And here if you are using Falcon, so 26.2% accuracy. And if you're using Llama 2 7B here, so see, accuracy is like very much increased here. It's around 45.3% of accuracy. And if you're using 7B, that and here if you're using 13B, that means 13 billion parameter version of the model. So here this is the accuracy, 54.8% of the accuracy. And here if you're using MPT's 30 billion, so this is the accuracy. Then I mean, it's like less than your Llama 2. And Falcon 40B actually will give you 55.4%. And if you're using Llama 65 billion, so 63.4%. And Llama 7B, like very good accuracy here, 67.9% of accuracy. Okay, so with respect to that, you can see this is again another data. So this is like MMLU data. So this is trivia QA data. This is natural questions data. So you have lots of benchmark data. With respect to that, these are the model has been trained, and this was calculated the accuracy. Okay, and this is the And this is the complete benchmark table. Here you will see all the performance of the model. Okay. And guys, if you want to test this Llama 2 model, so here there is a one UI has been published here. If you see on top of the Llama 2 model, so if you just write www.llama2.ai, so this is the chatbot actually you will able to see. So this is kinds of chat GPT kinds of interface they are providing, and in the backend actually they are using Llama 2 model here. If you see, so you can select Llama 2 model, different model. So by default it is selected Llama 2 7 billion. So let's select this one Llama 2 7 billion parameter, this model, and you can also give the your system prompt here. So let's take this prompt only, and the temperature you can also select. Let's say if this temperature is close to 0, that means this model would be more strict to the output, so it won't give you any randomness. And if you set this temperature as close to 1, that means